So today we are going to finish our transaction topic. Okay, right. So transaction we have halfway. We are in halfway. Last time we discussed what is a transaction, the acid properties of transaction, the main challenges, the concurrency control, as well as the recovery management, and also how to make it as efficient as possible. So we discussed that every database operation, whether it's insert, update, delete, or retrieve, it's set of read and write operations. We look at it as set of read and write operations. And we discuss what are the possible issues, the write, or the lost update, write, or the temporary update, or the dirty read, write, or the inconsistent summary, and possibly the phantom issue. Right. We discuss how these things can give us troubles. Then we discuss the transaction isolation levels databases supports. Read uncommitted, read committed, repeatable, read to serializable. Serializable is the strongest, where all these possible issues are tackled in serializable schedules. Okay. And then we start discussing about what is a schedule list, then what is a serial schedule list, and then what is serializable schedules are. So remember, serial schedules and serializable schedules are business logic wise valid schedules. Okay, because if it is equivalent to a serial schedule, it's also valid. So then we discuss there are two ways we can create serializable schedules: the conflict serializable schedules and the view serializable schedules. Okay, so serial schedules are valid, conflict serializable schedules are valid, and even view serializable schedules are valid. Okay, we discuss how to create serial schedules. If there are 3 transactions, there are factorial 3 number of possible serial schedules. Then we discuss what is meant by conflict serializable schedule. If a schedule is conflict equivalent to a serial schedule, one of the serial schedule, we say it is conflict serializable schedule. Okay. So then we checked how to check whether given schedule is conflict serializable schedule. It's very easy. You just write the relevant read-write operations of each and every transaction, and of course those will be mixed. Then you draw the precedence graph. If the precedence graph has no cycles, we say that that schedule is conflict serializable. And also we discuss how to find what is the equivalent serial schedule. So there we have to use sort of a technique where we start with any transaction with index 0 and keep eliminating one by one. Every time you pick a index 0 transaction, you have to remove all the outgoing arcs. Likewise, then again you have to keep looking for index 0 until you exhaust. So then that is your one of the possible serial schedule. You may ended up with 2 or 3 or multiple possible serial schedules as well. But as long as it is equivalent to at least one serial schedule, it is anyway, it is conflict serializable. So lastly, we discuss what is mean by view serializable schedule. Right? If a schedule is view equivalent to another serializable schedule, usually a conflict serializable schedule, though the original one is not conflict serializable, then this schedule is also considered serializable because it's view equivalent to a serializable schedule. And we discuss how to check whether a given schedule is view equivalent to another schedule. Right. So there are 3 conditions we have to check. Which transaction, the transaction that did the first write or the initial reads must be doing the initial reads in the second schedule as well. The transactions that did the final writes in the original schedules must be doing the final writes in the other schedule as well. Then all the write read conflicts must be preserved. So if so, we say that it's view equivalent. So if X is serializable and Y is V equivalent to X, then Y is also serializable, because Y is V equivalent to X and X is serializable, maybe complex serializable. So therefore our Y is also serializable. So that is where we stop. Okay. Then we briefly discuss about recoverability also. It's very important that in case of a failure, we must be able to recover. Okay, we must be able to recover the transaction. There are two possibilities, actually three possibilities: unrecoverable schedules, recoverable schedules without any cascade rollback, recoverable, but we have to do cascade rollback. So the first one is the troublemaker, because we can't recover. The other two are okay. Other two are okay, because anyway we can recover. Okay. Right, so we discussed that. Any questions up to that point? Because today we are going to move from that point onwards. I just uploaded the updated document to the Google Classroom, and also I posted it to the WhatsApp group as well. Okay. Right. So any questions up to this point? Right. So today we are going into the last time it is just checking whether given schedule is config serializable or given schedule is view serializable. So today we are going to look at how the databases on the fly in real time create serializable schedules, because serial schedules are not efficient. Databases always look for serializable schedules just to make them mix as much as possible when it proceed with the transactions. Otherwise, there will be huge queues, okay, in a busy databases. So there are two main approaches: the log-based transaction handling and the timestamp-based transaction handling. Those are the two things that we will be covering. But there are some other approaches like multi-version control, optimistic concurrency controls, etc. as well. Okay. So we'll be discussing the first two. Right. First, we will be discussing the log-based transaction handling. So in the exam, sometimes they ask log-based, sometimes they ask timestamp-based. So both are based on the same philosophy, same strategy, but two tactics. So that is how you understand. So log-based and timestamp-based, the underlying philosophy, underlying strategy is the same, but they are two different tactics. Okay, tactics. Right. So now let's look at the log-based transaction handling. In log-based transaction handling, the transaction access a particular record only if it can acquire the lock. It can acquire the lock. If the lock is not available, it has to wait. It has to wait till the lock is available to that particular transaction. That means lock is not available means another transaction has locked that record. Okay. So that is the idea. It's something like a lock of a washroom. Okay. So if you want to go to the washroom, if someone has locked it, you have to wait until that person come out of the washroom. That means the lock is released. Now another person can get it. But if there are few others who are also waiting, then they still have to wait, because only one can take the lock. Okay, that is the idea. That is the ethics. Okay, so then when the other guy release the lock or come out of the washroom, another one in the queue can get into the washroom. So that is the idea. Okay, right. So that is sort of an exclusive lock where only one person can be in the washroom. But in transaction handling, we use two types of locks. So what is known as the exclusive lock and the shared lock. Actually, in washrooms also we have both, right? So if there are two areas in the washroom, typically one area is where you have the mirrors and other things where multiple people can be. So that means a shared lock. Right? You can multiple people can be in this area, but we have the another areas where exclusive lock is needed. Only one person is allowed. Okay, so same concept, similar concept. In database locking also, we have what is known as shared lock, where multiple transactions can take it. But anyway, if you have a shared lock, unless you have the shared lock, you can't use it. Right? You can't use it. But exclusive lock is different. Again, you have, unless you have the lock, you can't use it, but only one can take that lock. Whereas the shared lock can be taken by multiple parties, multiple transactions at the same time. Okay, so it's very important to understand this and use similar examples, analogies in real world so that you can better understand. Okay, otherwise you may feel like you have understood it, but in reality you haven't understood it. So question, clarify, and somehow get it, make sure you before going to the exams you have fully understood it. Then you can go with a lot of confidence. Otherwise, your confidence will be very low. That is why the passing rate of the database subject is extremely poor. Okay, in overall, right? So lock is a two-state thing where you either have the lock or you don't have the lock. Okay. There's nothing called somewhat have the lock or whatever. No, it's a Boolean two-state thing. Either transaction having it or transaction is not having it. That is from the transactions point of view. And resource point of view also, either this resource is locked or is that resource is not locked or available. Okay. Right. So locking can be done at different levels. Okay. So you can lock only a particular record. Say there are thousands of records in a table. You lock only the record you want to access. That is the sort of a smallest granular or the level, which is better. Smaller the level, it is better. That means others can still use the other records. So the second level is you lock entire table. When you want to update a particular field record, maybe just one record, still you lock entire table. That means other transactions cannot access that table. And the third level is you lock entire database. You lock on entire database. Okay. So that means until you release the lock, others cannot do anything with the database. Right? ඒක හරියට අර VIP හාල් පාරුවේ පාර යනවා නේද? එයා යනකොට මුළු පාරම වහ ගන්නවනේ. අනිත්යට පාර යන්න විදියක් නැහැ. So that is how inefficient idiots do it, right? So same thing, that is a lock per database. But in software engineering, so we go for this one, lock per row or record where others can operate so that things are happening very smoothly. Okay, right. So I told you there are two types of locks, the exclusive locks and the shared lock. So exclusive lock means only one transaction can have it at a time. And once until it is released, others cannot access it. And again, if there are multiple transactions waiting, only one will get it. That is called exclusive lock. Then we have the shared lock where that resource, if the resource is operating on a shared lock, multiple transactions can take that lock. Okay. At a time, maybe 3 transactions have acquired that lock. So that is called shared lock. But anyway, without that lock, you can't use it. You have to get the lock, but you don't have to wait until all the others release it. While others having it, you also can get it. But unless you get it, you can't access as well. That is called shared lock. Okay. So in exclusive lock, we just have to check whether the lock is given to some transaction or not. It's a Boolean concept. In shared lock, yes, we have to check whether it's anyone has taken it or not, Boolean, but at the same time, we can just keep track of how many transactions are currently having that lock, right? So every time a particular transaction is given the lock, we have to increment the lock count, and every time transaction release it, we have to decrement it. So if the count is 0, that means no transaction has acquired that lock. Okay. Right. So the databases use 2 strategies The first strategy is the database 100% operate on only exclusive locks, right? They use only exclusive locks in transaction handling. So that means there are only two operations, the write operation and the read operation. In exclusive lock strategy, both write operation and read operations need exclusive locks. That means your write, every resource has two locks. And every resource has two locks, the write lock and the read lock. So if you want to write, you need the write lock. If you need to read, you need the read lock. So exclusive strategy means both write lock and read lock are exclusive locks. Only one transaction can have the write lock, only one transaction can have the read lock. Okay, so that is called exclusive lock strategy, which is not used much because it's not efficient compared to the second approach, where you have two types of locks. Okay, two types of locks. Here both are exclusive. In second strategy, again you have two types of locks, write lock and read lock, but here the write lock is exclusive. Right? Write lock is exclusive, but read lock is shared. Right? Read lock is shared. So that is the second approach. So that is the approach that we are going to discuss. Okay. Because this is more efficient approach. So the write lock is exclusive, whereas the read lock is shared. It's something like how we use washrooms. Okay. Right. So I told you that read this, you can consider it as someone get into the washroom and wash someone his hands, or just look at it in the mirror and see whether he's okay. So that is something like a read operation. And multiple people can come in, right? So that is accepted. Okay, so that is something like how the read operation occurs in databases. But write operations are someone is getting to the washroom for some other special needs. So then only one person can do that at a time. So that is how the write operations are done in databases. So the write operations can be considered as something like that, where you need the exclusive lock, whereas read operations you can get the shared lock. Okay, so I will be using this analogy, okay, because you need some sort of examples to understand the strategy behind this. Okay, right. So we are going to discuss about this approach where the write lock is exclusive and the read lock is shared. Okay. Now every resource has two locks. Okay, every resource has two locks, the read lock and the write lock. Right, so this is how the read operation occurs. Okay, this is how the read operation occurs. Okay, so this is, if write lock is available, then get the read lock or else wait on Katandar. Okay, so just give me 1 minute. I just want to highlight that one also. Okay, right. If the write lock is, now this is how we are going to get the read lock or read operation. When you go for the read operation, you check whether write or the exclusive lock, because write lock is exclusive, read lock is shared. You don't check whether read lock is available. You check whether write lock is available. That means no one has taken the write lock. Right? No other transaction has acquired the write lock. That means you can get the read lock. or shared lock. Maybe some other transaction also has taken it, but we don't care. We just check whether the Wright lock is available. If Wright lock is available, you get the read lock. That means you get the lock and the lock count will be incremented by 1. Okay, so that is, and if the Wright lock is not available, you have to wait for your read operation. Okay, we have to wait read operation. Okay, so let's get back to this analogy, because you must know why it is happening like that. So take the washroom scenario. Now, if that, say, if a person is occupied for that Wright operation, that special operation, now you are not supposed to get it, because a person has occupied it for that special thing. Same thing, right? So then you are not supposed to get in for to do your read operations, right? You are not supposed to get in and do wash your hands and other things as well. That is your read operations, because it's private things is happening. So that is why the same thing is there. If the Wright lock is taken by another transaction, you will not be getting the read lock. Actually, not only you will not be getting the read lock, no one should be getting the read lock. Okay. But if no one has taken occupied for that special operation, yes, right, that means Wright lock is available, but you don't need the Wright lock. You just get the read lock. You just get the read lock, because your objective is different. Okay. Right. I hope you got it. If read lock is already taken, you don't care. So that means another person has getting to do some washing hands or whatever. You don't care. You also get it. You also getting, and you get the read lock. And your only concern is whether someone has taken the Wright lock. Right. So that is the lock strategy for read operation. Right. If Wright lock is available, then you get the read lock. That means you increment the lock by read lock count by 1. Else, you wait until the Wright lock is available. So 0 means Wright lock is now available. Then you go to this point and get your lock. But it doesn't guarantee that you will always get it, because if others are also in the queue, maybe some other transaction may get the read lock. Okay, before you. But again, you may also get it, because if 3 transactions were waiting for the read lock, then all 3 will be getting the read lock, because if one transaction getting read lock does not prevent you from getting the read lock. But say these 3 were waiting for read lock and this guy was waiting for Wright lock and you are waiting for read lock, and then you may not get that lock as well, because this guy is waiting for Wright lock. Okay, so that kind of complications can be there. But that you will understand when we do discuss the lock strategy for the Wright operation. Okay. Right. Any questions? Any questions on this? Right. So if you don't have questions, we can move very fast. So that means you understand perfectly. Right. So now let's see what is the lock strategy for Wright operation. Right. What is the lock strategy for Wright operation? Right. So in Wright, if you are looking for Wright operation, you have to look at both Wright lock and read lock. You have to check whether Wright lock is available as well as whether read lock is available. If both are available, that means no one has taken Wright lock and read lock. You get the Wright lock, that exclusive lock. Or else you have to wait. Or else you have to wait. Okay. Until again you have to check after some time. Or else you just wait in the queue. You will be notified by the DBMS when the both are available. Okay. It's something like, now again you want to get into the washroom to do that special thing this time. You have to check no one has getting to do this special thing or no one is doing this other thing. because you are going to do that your private thing. So therefore, you have to check whether both read locks and write locks are available. No one has taken the read lock. No one has taken the write lock. Then only you get the write lock. Okay. So that is the lock strategy for write operation. Right. That is the lock strategy for write operation. So you look at both write and read lock. If both available, you get the write lock. You get the write lock, which is exclusive lock. Right. So now we are looking at some more concepts. Now, whenever your task is done, whether it's a read operation or write operation, you have to release your locks, because otherwise others are waiting. Other transactions are waiting. Immediately after your task is done, your transaction is either rollback or committed. You have to release that lock. Okay. And later we will discuss. It's not when you're done with the transaction, you can release it even before also. Okay. You can release it even before your transaction is done. So that we will be discussing how the lock releasing, what are the lock releasing strategies are. But for the time being, let's assume we just have to release it immediately after our transaction is either rollback or committed. Okay. Now that is, if you wait until your transaction is rollback or committed, it creates some inefficiency, because until you do all the stuff, you are not releasing it. You are not releasing it. And others are waiting. Other transactions are waiting to get the lock. So therefore, what you can do is, there are situations where you may downgrade a lock or you may upgrade a lock. So downgrade a lock means you had that write lock or the exclusive lock, but now you don't need it anymore. Your task is done, but still you need the read lock for do some other activities. So then you release your write lock, that which is the exclusive lock, and you acquire the read lock. So that is called lock downgrade. Lockdown. Release your write lock and get the read lock. And it is called lock downgrade, because still anyway you are having a lock. But now you have the read lock rather than the write lock. Okay, so that is called lock downgrade. So lock downgrade can always happen. Always happen in the sense, if a transaction need to do a lock downgrade, it can always do it. Because remember, read lock cannot be obtained until the write lock is released. Now you are having the write lock. When you are having the write lock, you can always exchange it to a read lock, because you are now downgrading. Okay, it's something like, I'm always taking this analogy, you getting to do this special private thing, but now just you want to wash your hands or check your face. So because you are the only one here, you can always do that and get out. Because you are the one having the right lock. So same thing, then you do a downgrade first, then you do your stuff and you get out. Then you release your read lock. So then someone will ask, why do you want to do that? Can't you just do everything while you're having the right lock? Then it's inefficient, because once you downgrade to read lock, others waiting for read lock can also get in and do their tasks. So we always facilitate that. So that every opportunity is given for others also to do their activities. Other transactions are also given opportunity as much as possible so that their activities can be done. If they are waiting for do some read operations, now they can also get the read lock. So that is the idea. It's a democracy. It is not taking all the resources. You just take the minimum resource, minimum privilege, etc. Okay, so that is called lock downgrade, which help better performance of the database. So the next one is lock upgrade. So lock upgrade means you're already having the read lock or the shared lock for that particular resource or record. Now you need the write operation to be done. Remember write operation, maybe earlier you needed to do the read operation. Now only you want to do the write operation. Now in order to do the read operation, initially you take only the shared read lock. Now your read operation is over, you want to do the write operation. Now you have to exchange your read lock or the shared lock with a write exclusive lock. You release your read lock and acquire the write lock. Okay. So that may also be possible because when you have the read lock, no one else can have the write lock. Remember? Because no one can take the write lock when others have taken the read lock. So therefore, again, there's a high possibility that you can get that write lock immediately because no one is having the write lock when anyone is having the read lock. Most probably you can get it. Most probably you can get it. Unless another transaction is also waiting to do that. But again, there's no guarantee that immediately you will get the lock upgrade because while you are taking the read lock, maybe some other transaction has also taken read lock. So therefore, you will not immediately get the write lock. You have to wait until the other transactions get out of this resource or release the lock. Once your read lock count is 0 only, you will be able to upgrade it to write lock. Okay, because write lock cannot be given when others are given the read lock. So you have to wait until they release it. So therefore, lock downgrade is immediately possible. Whereas the lock upgrade, you may have to again wait. You may have to wait. And then you will be able to get the upgrade done. Hari? Right. So unlock, we have to do immediate. So that is lock upgrade and lock downgrade. But if you don't need any lock anymore on that resource, you can simply release your read lock or simply release your write lock. In other words, you can simply release your shared lock or simply release your exclusive lock because you have no interest on that resource anymore. So once you release your write lock or exclusive lock, it will your DBMS is going to wake up a particular transaction which is in the queue at the front, which is waiting for either read lock or write lock. Because the read lock ganna balang inna, write lock ganna balang inna, right? So if some transaction is waiting for read or write lock, the first transaction will be notified. Okay, when you release your write lock. Then when you release your read lock also, maybe some transaction are waiting for the write lock because no one is waiting for the read lock while you are having the read lock. Then those who are waiting for the write lock or exclusive lock may be notified, but again it will be notified only if the lock count is 0. Just because one transaction released the shared lock or the read lock, it doesn't mean that those who are waiting for the exclusive lock will be notified. They will be notified only if the lock count is 0. Because maybe some other transaction has already also taken the read shared lock and they are still not released it. When the lock count is 0 only, the transaction waiting for the exclusive lock will be notified in the queue. The first one in the queue will be notified. Okay. Right. Any questions? Now we are done with that. Right. So if you don't have any questions, we can proceed. Otherwise, I will explain. You have only a few weeks to your exams as well. Okay, so now we are going to discuss possible issues in lock mechanism. Possible issues. We are going to discuss Actually, we are going to discuss three possible issues: the deadlocks, the need for cascade rollback, as well as lock starvation. So lock starvation we'll discuss later. Right, possibility of deadlocks. So you may have seen this frequently in countries like Sri Lanka, right? So in the roundabout, not roundabout actually, junctions, they deadlock the vehicles like this. So then if there are so many vehicles also here in the queue, now you are in a sort of a real deadlock. Because now all the vehicles have come closer. Now there's no way for these vehicles to move unless one party decided to push back. Right? Because there's no way, no other way. So then when these guys push back, of course, now this vehicle can go, and then they have to stop somewhere. Then these vehicles can go. Then they have to stop voluntarily, and these vehicles can go. Now again, it's performing properly. Again, if you get into this kind of a situation, again there's a deadlock. Again, one party has to compromise. One party has to compromise. Step back. Okay. So whenever there's a deadlock, one party has to compromise. Not all four parties. This is a junction anyway. Deadlock can happen between two parties as well. In transaction, deadlock can happen between two parties. In a junction, it is between four parties. So one party has to compromise, take a step backward. So that in transaction analogy, if there's a deadlock, one transaction has to roll back. There's no other option. Voluntarily, actually it's not voluntarily, the database is going to do it. It will pick one of the transaction and roll back because there's a deadlock. Right. So how can deadlock happen in a database transactions? So it happens when there are two transactions, say transaction 1 and transaction 2, which need to access both resource 1 and resource 2. And of course, there are some other resources also, but as part of the transaction 1's activities, it needs to access both resource 1 and resource 2. That means maybe this record and that record, maybe two different tables or same table. Assume that transaction 2 also need to access those two exact resources minimum. Okay. Now what will happen is, assume transaction 1 has locked resource 1. Transaction 1 has locked resource 1. And remember, the schedule can be, we can mix those activities in a schedule. Now the transaction 2 has locked resource 2. Okay, say transaction 1 has locked Y. Transaction 2 has locked X. Say this is X, this is Y. Now transaction 2 need to access, sorry, it's other way, right? Transaction 1 has locked Y. Okay, other way. Let's assume this is Y and this is X. Now transaction 1 has locked Y, and then transaction 2 has locked X. Now transaction 2 want to lock Y in order to proceed, but anyway it is already locked. Until transaction 1 release it, transaction 2 will not get it. Say it's exclusive lock we are looking for. Now this guy is waiting for Y lock availability to get the lock Y. Now the next step of the transaction 1 is access X. So therefore now it needs a lock of resource X. But unfortunately X is locked by transaction 2, which is waiting for lock Y. And you have locked resource Y, and now you are waiting for resource X. Now you can see that these locks are never going to be released, because assume that you don't release your locks until your task is fully done. You are going to release the locks only when you are either committing or rollback. But you can't commit to a rollback because you have to do another step. So this guy cannot do this part. Transaction 1 cannot do this one. Both are waiting, hoping that after sometimes the lock will be released. But in reality, these locks are never going to be released. It's a cyclic dependency. So that is called deadlock in transaction handling. Right? So this is called deadlock in situation in transaction handling. This is never going to resolve. If the database is up for next 10 years, these transactions stays waiting for the next 10 years, right? Unless your database mediate and resolve this. So that is what is mean by deadlock handling. Okay. So there are two tactics the database management systems use in deadlock handling. So the first approach is deadlock prevention or avoidance strategies. So that is before these deadlocks are happening, the database proactively prevent that. Okay. So the second approach is it frequently or periodically check whether there are deadlocks. If there are deadlocks, it will resolve it. Resolve it in the same things. We have to roll back one party, one transaction, and then the other transaction can proceed. So the deadlock prevention mechanisms as well as deadlock detection and resolution. So there. Right. So when it comes to deadlock prevention, there are two approaches, two tactics: the wait die and wound wait. Okay, wait die. Actually, both are the same thing, same strategies actually, but two tactics. Okay, two tactics: the wait die, wound wait. So this is more relevant when it comes to timestamp based transaction handling. Okay. So the wait die and the wound wait. Right. What happens when it comes to wait die? Wait die. So that means either you wait or you die. Okay. Anyway, we'll discuss this when we are doing the timestamp based transaction handling, because this is more relevant to the timestamps. Okay. I will come back to this when we are doing the timestamp based handling, because still we are discussing the log based transaction handling. Still we have not done with the log based. Then we'll come back to this wait by die and wound wait. Okay. Right. So what is deadlock detection and resolution? So that we can finish discussing right now. In deadlock detection and resolution, your database management system periodically check whether there are cyclic dependencies. Cyclic dependency means something like T1 is depending on T2 to proceed, T2 is depending on T1 to proceed, or T1 is waiting for T3 to proceed, T3 is waiting for something that T2 has to release, T2 is waiting for something that T1 has to release. So that is also cycle. It can be between 2, 3, 4 or any number of parties. So it will check for these things periodically, and if it detects this kind of situation, it will pick one of the transaction and roll back. Then, of course, the issue is resolved. Now at least the other transactions can success. Then, of course, the transaction that the DBMS decided to roll back has to be redone, because that transaction must be done. So immediately, when others are success, now again you are redoing that transaction that you roll back. Or you have to notify the relevant party, relevant customer, or the relevant user, saying that this transaction was not success. So then at least the person knows that there was a failure and I have to redo it, or I have to just check with the business organization what was the reason for that. They are not interested in the technical reason. They are just interested whether your transaction is done or not, right? For example, you are doing a money transfer. So you are not interested what really happening inside their system, right? What you are interested is whether that money transfer done properly or not done. If it is not done, they have to properly say, no, it was not done. That means you know that, okay, if it is transferring money between two accounts, between your accounts, you know that this account is not debited, the other account is not credited. So I can do it again. Okay. So you are just interested whether it's success or not, because failures can happen, right? For various reasons. So that is what happened here. One transaction will be rolled back and others will be proceeded. And the DBMS will again restart the failed transaction, or it will just notify the customer saying there was a fail. Right. So this one we will revisit later. Right. So this is the preventive measure. We will revisit later. Right. So now we are going to discuss two-phase locking mechanism. So I told you that there are two strategies. One strategy is you release your locks only after you are done with all the activities. Say you have to do 5 activities. Your transaction has to do 5 activities. You do all your 5 activities and then you release the lock. Release the lock. Maybe you have acquired the lock of resource X, Y, Z. You're acquiring, but you're not releasing. You are releasing only at the end. Maybe at the end, you know, either it's commit or rollback. So after commit or rollback, you release all your locks together. Okay. So that is one approach. The second approach is you release your locks gradually. Once you are done with the resource X and now you are working with resource Y, you tend to release this lock X so that others has a chance to acquire it. Okay, so that is the second strategy. So this strategy is more safer. This is a safer approach, but it is overall inefficient. This approach is little bit risky thing because you may have to roll back and blah blah blah, right? But this is more efficient approach. So therefore, databases try to do this as much as possible with a lot of cautions, lot of tactics to prevent the undesirable effects. The databases try to do this more than this. Okay, so that is where the two-phase locking. So this is a single phase locking. You acquire and at the end only you are releasing. But here you have two phases. So we have the lock growing phase and the lock shrinking phase. Lock growing phase means at that phase, we are acquiring locks, but we don't release locks. In unlocking or shrinking phase, we gradually release locks. Okay, we gradually release lock. And we don't acquire now. So those two phases are mutually exclusive. Here we acquire but don't release. Here we release but don't acquire new locks. Okay. So those two phases must be mutually exclusive. Right, now let's see what are the 3 tactics or 3 strategies in two-phase locking. The basic two-phase locking, strict two-phase locking, and strong strict two-phase locking. Okay, so the basic two-phase locking. Now, if you have any doubt, you have to ask. It is your responsibility, right? I can't ask questions on behalf of you. My responsibility is only if you ask questions, clarify it. Okay, I can't study on behalf of you, right? It is your task, your role. Right. So what is basic two-phase locking? In basic two-phase locking, we have again two phases. That is why we say two-phase locking. So we have the acquire phase where we acquire locks. Okay. And in the release phase, we gradually release both read and write locks, or the write exclusive and shared locks. We gradually release both read locks and write lock. But until you come into the second phase, you don't release. So here you only acquire. Now you start releasing, but when you are releasing, you release both read locks and write locks. So the shared locks and exclusive locks gradually. So that is called basic two-phase locking. Okay. So anyway, in all these three tactics, the deadlocks are possible. Okay, deadlocks are anyway possible. But in this approach, the cascade abort may be needed. I explained you what is mean by cascade abort last time. Okay, so that possibility is there in basic two-phase locking. Okay. So then we have the strict two-phase locking. S2PL, strict two-phase locking. Again, two-phase locking, we have the acquisition phase and release phase. So during the acquisition phase, you don't release anything. Now in the release phase, you release only read locks. You gradually release read locks. Now this is the lock count. Lock count, you can see it getting down because you are releasing the read locks gradually, but you never release the write locks. Here you release both read and write lock gradually when no longer you need it. But here you don't release the write locks, you're only releasing the read locks. And at the end only, you are releasing all your write locks. So that is called strict two-phase locking. It's stricter than this. This is very liberal two-phase locking because you release both read and write. Okay, we release both read and write in this second phase. But here we release only read locks and write locks we release only at the end. Therefore, this is strict version, strict two-phase locking. So then we have another approach called strong strict or rigorous. So strong strict means now the word strict is already used. We want to make it even more restrictive. So then people came up with the word strong strict. Strong strict. It's even stricter than strict. SS2PL, strong strict two-phase locking. There, when you are releasing, you release both read and write locks at the end. Actually, this should have been something like this. Acquisition phase, then you stay there. Then all of a sudden you release. Actually, it could have been better diagram. So you gradually acquire. Then you are finishing your transaction. You are not releasing anything. But now you are releasing both read and write. Both read and write together at the end. So that is called strong strict two-phase locking. SS2PL. Right. Out of these approaches, this is risky approach because cascade rollback may be happen. This is unnecessarily strict approach. So this will unnecessarily create some inefficiencies. So this is the sort of a efficient and manageable approach. So it's efficient than this one. Sorry, it's efficient than this one because here you are not releasing anything until end. But here you are releasing the read locks. Okay, it's efficient than this one. And this one has less trouble than this because this one has a trouble of cascade rollback. But this one doesn't have that issue also. So therefore, this one is not having that issue. At the same time, this is reasonably efficient. This one has no issue, but it's very inefficient. Okay, very inefficient. So therefore, typically databases prefer strict two-phase locking, where during the acquisition phase, you acquire both read and write locks. During the release phase, initially you start releasing the read locks, but at the end only you are releasing your write blocks. Okay. So then someone will ask, what is the idea behind this? Because everything must have a why this is better. Right. So the reason is the troublemaker is the write locks. Because if you release write locks, others can acquire the read and write locks of that particular resource. But read operation is a very innocent operation, right? Read operation. So you are now releasing read operation, because if you get the read operation, you release it. Release it. So that's if another transaction is waiting to get the write lock, now it can get it. Now it can get it because you release your read lock. Okay, but you don't release your write lock until the end. Until the end, because write lock is more stronger lock. It's more risky lock to release. So therefore, you just keep it, but you release your read lock so that others can get the write lock. Okay, so that is the idea behind strict two-phase locking. We release the read lock, but you don't release the write lock until the end. So here you don't have that cascade rollback issue because you don't release the write locks, right? If you release the write lock only, that cascade rollback can happen. Cascade rollback is it's not an unrecoverable schedule, but anyway, if we can prevent cascade rollback, that is also good. So this prevent cascade rollback at the same time, it facilitate other transactions to proceed as well in certain level. Okay, right. So those are the lock releasing strategies. What we use is, in general, the strict two-phase locking, because this is too strict and this has the cascade rollback issue, the basic two-phase locking. Okay.
Excuse me, sir.
Yes.
When S2PL, how can someone acquire the write lock until we release the write lock?
No, we may be having only the read lock. Say we have the read lock of resource X and read lock of resource Y. When we release the read lock of resource X, maybe we are the only party that is getting that read lock. So then another transaction can get that write lock. Okay, because we are acquiring different locks. We are not working with only one resource, maybe X, Y, Z. When we release the read lock of X, that X can be accessed by another transaction. Still it is confusing. No?
It's okay.
Okay, right. So the idea is we are keeping we are working with multiple resources. Maybe some resources we take the shared lock, some resources we take the exclusive lock, blah, blah, blah. When we release the shared lock, some other transaction may be able to get that lock. While those who are waiting for our resource Y, they have to wait, but we give them some opportunity, right? We give them some opportunity, right? Right. So where is the lock starvation? Okay, starvation. I missed that part. Right. So what is mean by starvation or lock starvation or live lock? So you know what is mean by starvation. Starvation, what is the meaning of starvation? It's a sort of unbearable hunger. Like suffering or death caused by lack of food. And so what is my lock starvation? Or sometimes we call it live lock. You are not deadlock. So deadlock is dead. You have no option until other party mediate. But live lock means you feel like you are alive, but actually you are sort of a die. Live lock. Okay, live lock. So that is, say you are waiting for a lock. Right? You are in the queue. Say transaction 1 is in the queue waiting for the particular lock to release so that it can proceed. And now other transactions also join the queue. Say transaction 2, transaction 3, they also join. Now typically what will happen if you are in the front of if you come to the queue first, you will be served. When the lock is released, you will be given the lock. But there's a concept called prioritizing transactions. Now say you are in the queue, the high priority transactions come into the queue. Now you are again going back of the queue. Now when the lock is released, that transaction get it. You are still waiting. While you are waiting, another transaction, another high priority comes. And you keep in the queue for very long time, expecting a chance, but you never get that chance because while you are waiting, high priority transaction again get into the queue. So that is called starvation. හරියට gas පෝලිම් කොටලා බලන් ඉන්නවා තමයි. හරි. gas එනකම් බලන් ඉන්නවා හොරපාරෙන් යනවා. ආපහු. So that is lock starvation or live lock. Okay. So that's very simple concept, but it can happen, right, in a database, very busy database. And we have to detect those as well. And we have to detect those as well. And database management system has to involve that kind of activities and let those transactions also proceed. Right. So now what we are going to do is, before time-based transaction management, we are going to do some past paper questions. Okay. Right. So let's do this one. Consider the following schedule less. This one we did, I think, last time. You should be able to do this one. Okay. We did this kind of questions last time. Consider the following schedule less involving transaction T1 and T2. If the above schedule follows two-phase locking protocol, identify all the locking activities. Right? Identify all the locking activities. Now here you can assume that you release locks at the commit or rollback. Okay, so though we call it two-phase locking, so for your simplicity, in the exam paper, you can always assume that you release only, locks are released only when you commit. Okay, only when you commit. And so the question is, consider the following schedule less involving transaction T1 and T2. If the above schedule follows two-phase locking protocol, identify all the locking activities. It's very easy question. So this is a read operation. What will happen here? The transaction 1 will acquire read lock, right? Read lock of X. So read X is acquired by transaction 1. Okay, so you have to write it a suitable way. For example, I can say something like transaction 1 read X. Okay, read X. I will always keep track of which transaction is having which lock. So this is X resource. Now the read and write locks are there. Read lock keys or the shared lock keys with the transaction 1. Okay, transaction 1. Now it is doing some activities, then you need the write lock. So that means here transaction 1 will get the write lock, or actually the examiner will use S and let's see. No, can shared locks are exclusive lock here. So let's say this is shared lock. Now say this is read and write, or shared and exclusive. Okay, let's call them shared and exclusive also, because then it's easier for us. Shared lock means read lock, exclusive lock means the write lock. Okay, now the transaction 1 has the shared lock. Now transaction 1 will upgrade it to exclusive lock. So the usually examiner doesn't care about upgrades. Okay, so he will mostly just say, okay, you have the exclusive lock as well, right? But in reality, maybe you will release it, but for the time being, let's say now the transaction 1 has both shared lock and the exclusive lock of X. Now this point, let me write it a little bit smaller. And so here transaction 1 shared X, here transaction 2 exclusive X. It is actually here and this level. Okay, now transaction 2 need the read lock. Now remember, when you are looking for the shared lock, you check whether exclusive lock is available. That's all we are looking at. But now the exclusive lock is not available, because it's now the exclusive lock is also with the transaction 1. So therefore, and the transaction 1 has to wait. Transaction 1 wait for which one? Of course, it needs the shared lock, right? Shared X. But in reality, it is waiting for the exclusive lock to release. It is looking to get the shared lock, but it is waiting until the exclusive lock is released. So it has to wait. So still it is waiting. So it can't do anything here, because it is waiting for the exclusive lock to release. Right? So nothing happens here. Okay. If you want here, you can see transaction 1 is waiting for exclusive lock of X as well. Okay. It's waiting for shared lock and it is waiting for exclusive lock. Still you haven't got it. Now transaction 1 is reading Y. No one else has taken Y. So it will acquire. Now Y also has the shared lock and exclusive lock. Now transaction 1 will acquire shared lock of Y. Now transaction 1 is having that. Now Y is doing.
Previous one is transaction 2, no?
Which one? Yes, sorry. So this is transaction 2. Yeah, thank you for that. Okay. So this is transaction 2. They are waiting. Right. Now the transaction 1 get the shared lock of Y, and also it can get the shared lock, exclusive lock of Y also here. Transaction 1 exclusive lock of Y is also taken by transaction 1. And now it commits. So at commit, it can release all that is our assumption here. Okay. So actually we are talking about, because just to make it simple, that is the approach you are expected to do. Now transaction 1 can release all the locks it has acquired. So that means this shared lock, this exclusive lock, this shared lock, and this exclusive lock. Forget about the lock upgrade. Okay. For the time being. So that means it release, right? Release shared X, exclusive X, shared Y, and exclusive Y. Now all these locks are released. All these locks are released. Now, once you release those things, now this guy is waiting for the shared lock of X. Now this guy can get it. Okay, so now at the same step, now this is T1, this is T1. The T2 will get shared X. Now T2 has, now these are released. Now T2 will get the shared lock, right? Because it was waiting for shared lock of X. Okay. And also now it can proceed. And also it can get the, because when you get the shared lock, you can get the exclusive lock as well. Right? At the same time, T2 will get the exclusive lock of X as well. Okay. Now it can proceed these 4 steps because it got the shared lock of X and exclusive lock of X. Now in this point, at this point, those things are happening, and now it has proceeded these 4 steps after this is committed. Now here, transaction 2 is acquiring shared lock of Y. Now shared lock of Y is with the transaction 2. Now it is acquiring transaction 2 is acquiring exclusive lock of Y as well. Now the transaction 2 is having exclusive lock as well. Now we are committing. So at this step, you have to write that you are releasing all the transaction 2 release shared lock of X, right? Shared lock of X, exclusive lock of X, shared lock of Y, and exclusive lock of Y. All 4 locks are released. Okay, shared X, exclusive X, shared Y, exclusive Y. And let's see whether the examiner has considered lock upgrades. Right? Usually, examiner does not consider lock upgrade. He will say that while you are having the read lock, you will be taking the write or the exclusive lock as well. But let's double check. Okay, right. So that is the lock activities happening each and every step. It's very important at this step you release those locks and other transaction get those locks because no other transaction is waiting. Okay. Now let's see the examiner's one. Right. So you can see that here the shared lock of X is acquired. Okay. Now before doing this, exclusive lock is acquired. So that is what I mentioned here. Shared lock and exclusive lock is acquired. Now this is waiting for lock.
Excuse me, sir.
Yes.
එතන excuse lock එක ගන්න sir T1 ද T2 ද?
මේකද?
ඔව් sir.
T1 මේ තියෙන T1 ගේ transact activities නේ. මේ තියෙන T1 ගේ.
අතර අපේ note එකේ T2 වගේ දැක්කම.
හරි හරි. ඒක T1 නේ. ඒක මම වරද්දලා ඇඳලා තියෙන්නේ. මේක T1 නේ. Right. So it must be T1. Sorry. T1 take the shared lock. මේක T1 ම තමයි. T1 take the exclusive lock. Actually I made a mistake. Okay. I made a mistake. Yes. So T1 take the shared lock. Now T1 take the exclusive lock. Now it is waiting. T2 is waiting for the shared lock. Actually, it is waiting for the shared lock. Now it is waiting for the exclusive lock. The examiner has not mentioned it twice, but in reality, you have to mention here waiting for shared lock. Here waiting for exclusive lock of the X. Okay, exclusive lock of the X. Now it is taking the shared lock of Y, transaction 1. Now it is taking the exclusive lock of Y. Now you commit. Once you commit, you can release all the locks. That means you can release the shared lock and the exclusive lock of X and shared lock of X and exclusive lock of Y. Okay, here in reality, it can do a lock upgrade also, because once you are done with that, if you want, you can get the release the shared lock and get the exclusive lock. But examiner usually do the answers does not go into that kind of complications like lock upgrades and lock downgrades. The examiner will always consider that, okay, I am having all the locks and I will release all the locks. Okay, so that is a that is, I think, just to make your life easier and make the answers simple, right? So you don't have to worry about lock upgrades and downgrades in this kind of question. Right now, it's very important, once you release, immediately this guy is waiting for read and write lock. This guy get the locks. Actually, here you need only the first the shared lock, then the exclusive lock also. Okay, so that it can proceed with these steps. Now it is acquiring the read lock, because now only it want to do this. Then it acquire the write lock. Here it is read lock and write lock is mentioned separately. Then you do it. Now you are releasing all the locks. Read and write lock of the X resource and read and write lock of the Y resource. Okay, so that is not at all a difficult question. It's a very easy question, right? So you must find a way to write the answer. So in different years, the examiner, because this database subject has been coordinated by different lecturers. I think the last time it was, I think, the late Professor Vikramanayak, I think. So was the course coordinator for this topic. Yes, I think for last 2 years. Now he is no longer there. I think new lecturer is there, course coordinator is there. So they will use different style. They will use different style. So this is the style that used by the last exam paper. Of course, this time maybe a new examiner again. I don't know. So anyway, you have to just explain it in a proper way so that the examiner can see that you know the concept. Okay, so that is the idea.
Excuse me.
Yes.
So එතන දීලා තියෙන releasing Xlocks කියලා විතරයි නේද? Deadlocks 4ම release කරනවානේ. commit වුණාට පස්සේ.
කොතනද?
මෙතන මේ උත්තරේ තියෙන release Xlocks for XY කියලානේ. එනවාට lock මේ shared එකයි exclusive දෙකම release කරනවානේ.
ඔක්කොම release කරන්න ඕන. හරි ඒ ලියද්දි පොඩ්ඩක් මේව කරලා තියන්නේ. ඔයා shared log ගන්න shared logුත් release කරන්න එපා නේද? examiner පොඩ්ඩක් එච්චර strictly ලියන්නේ නැහැ. Right? Basically you have to release all the logs. Yes. Right? You have to release all the logs because no point keeping the shared log after you commit, right? Yeah. So it's I think a small just to make it simple, they have just written X logs. You have to release all the logs. Or else maybe examiner has assumed that when you get the exclusive logs, it's a lock upgrade, right? Lock upgrade, then you don't have to release it. But then you have to say here you release. Now, if it is a lock upgrade, when you write here, say this is you are getting the shared lock and now here we say shared lock and exclusive lock together. Actually, here only you need the, sorry, here you need the shared lock of Y. Here you need the exclusive lock of Y. If you are releasing only exclusive lock here, you have to mention here that we release the shared lock of Y. And we release the shared lock and get the exclusive lock. But the examiner has not done any of those. He is not mentioning here you are releasing and here also he is not mentioning releasing. So either you release everything here or when you get this, you have to release the shared lock. That means lock upgrade. But unfortunately, examiner has mentioned none. Okay. So it's up, it's open. I have never seen examiners mention about lock upgrade, downgrade. So you can just assume that ultimately you are releasing all the things. So you can put up a small note and say there can be lock upgrade here also. So, okay. So you have the flexibility to write some assumptions. So some notes saying that these and these possibilities are there. Make sure somehow you convince the examiner that you know the concept. You know the concept and you know the possibilities. Okay. So these model answers, they write it in a very brief manner. So you have the opportunity to write those things in a little bit more detailed manner, and maybe multiple possibilities are there. You can just write it that, okay, this possibility is also there. Okay, because you are final year students, you must be able to explain it because this is structured, not a structured paper, this is essay paper. Okay, right. Right. So this is a recovery question. Actually, the 2020 paper that was one of the easiest question. Usually you get big questions with a lot of transactions. This is precedence graph. We did this kind of things. This is recovery question. This is again timestamp protocol. So we have not done that yet. Let's take another paper. Right, so this is much more comprehensive question, a little bit older paper. Let's do this question, okay? This is 2015 paper. Right, so this is the transaction. So this is related to this one. Okay, we'll do the full question. Okay, full question. Consider the following schedule. This is the schedule. The first part is draw a precedence graph for the above schedule. Indicate if the graph has cycles or not. I don't know whether we did it last time. Anyway, we'll do it again because we want to go into the looking part as well. Draw a precedence graph for the above schedule. Indicate the graph has cycles or not. If the above schedule is serializable schedule, determine all the equivalent serial schedules, and if not serializable, indicate why it is not serializable and identify the type of conflict. Right? Note that R1, Ri, and Wi denotes respectively the read and write operation of transaction I. So W3 means write by transaction 3 on C resource, right? And Ti for the data item A, B, C, D, and E. Okay, so first draw the precedence graph and check whether it is serializable or not. And if it is serializable, what is the equivalent serial schedule or possibly equivalent schedule, or if not, what is the reason? Okay, so first do that, then we move on to the locking part. So here itself, clarify all your questions, okay? Because this is a subject where it's very difficult for someone to learn by self-studying, right? There are some topic you can self-study, but this is, it will take a lot of time, but if you clarify this from someone, your time is, lot of time is your saved, okay? Okay, so let's do it. Let me copy it so that I have enough space. Okay, so let's do. You can use whatever the style you like. So I like this approach. Right. So this is transaction 1, transaction 2, transaction 3, transaction 4, transaction 5. Transaction 2, transaction 3, transaction 4, transaction 5. So transaction 1, write day. Transaction 2, read day. Transaction 1, write B. Transaction 3, write C. Transaction 2, read C. Transaction 4, read B. Transaction 2, write D. Transaction 4, write E. Transaction 5, read D. When you write like this, it's easier to see the dependencies, okay? And transaction 5, write D. Write D, okay? Right. Now let's draw the precedence graph. Remember, the dependencies are only between different transactions, and when at least one of the task is write operation, okay? So this is write, this is read, there's a dependency, write and read. So that is T1 to T2. Then this is new resource, this is new resource. Now write and read, that is T3 to T3 to T2. If I make a mistake, just let me know, right? So this is B. We have B here, so that means we have dependency. T1 to T4. T1 to T4. Then this is write D. Write D. So D is the first time we are using, no issue. E first time we are using, no issue. Then read D. Read D means there's a dependency between T2 and T4. So T2 and T5. T2 and T5. Then E is a new resource. No, E is not a new resource. Right? Now E is not a new resource. T4 and T5. Now see whether there are cycles. Right? No cycles, right? So no cycles are there. I think we did this one also last time anyway. So no cycles are there. So therefore this is serializable, right? Conflict serializable. So what is the equivalent conflict serializable schedule? You have to go with the in degree 0. Okay. So either you can start with T1 or T3. I will start with T1. Okay. So if I start with T1, now these two are not there, because T1 has in degree 0, then I can go for either T4, T2 or T3, any of these. Okay, I will go for T3, and this is also not there. Now I can go for either T2 or T4. Okay, so I will go for T2, and this is also not there, then I will go for T4, and this is also not there, then I can go for T5. So that is one possibility. Just one possibility. So many possibilities are there. I can start with T3, right? So I will just write another one. Say T1, then I can go for T2, T4, or T4, T2, right? T2, T4. Then I can go for even, now I can go for T3, right? Now I can go for T5. So that is another possibility. Likewise, there are some other possibilities as well. Even I can go for T1, T4, T2. Sorry, T1, T4, T3, T4. Right? T1, then these two are not there. Then maybe T4. Right? T4, then T3 and T2 and T5. So many possibilities are there. Okay. Right. So likewise, I think there are two more possibilities. So let's double check that part. I think we did this last time also. Right. So it has not shown you the diagram. Okay. But anyway, so these are some possibilities, right? So T1, T3, T2, T4, T5. T1, T3, T4. Let's double check whether this is possible. T1, T1, 3, 1, 3, 2, 4, 5. Okay, 1, 3, 2, 4, 5. Let's see whether it's possible. Because so many possibilities, I just wrote few. Let's see whether this is possible. T1 is possible. So then these two are not there. Then T3 is possible because in degree 0, then this is not there. Then T2 is possible because both are not there now. T2 is possible, yes. When T2, this is not there, then T4 is possible, right? T4 is possible. When this is not there, then T5 is, yes, this is possible, right? I told you there are so many possibilities. So this is another possibility. If they ask you to write all possibilities, yes, you have to write all, okay? But I don't know whether they ask all possibilities, but they ask. Indicate if the graph cycles are not. If the above schedule is serializable, schedule determine. Oh, yes, all the equivalent serial schedules, all. So that means you have to write all. I think examiner has written only few here, 3, but actually there are more than 3. More than 3 possibilities are there. So because we write 3, and this is a different one. T1, T3, no, this is same as this one, right? So this is same as this one. I think there's only 3. Just double check. There can be even 4 possibilities. Okay. So anyway, we also found this 1, 3, 2, 4, 5. Okay. So likewise, you have to. Examiner has asked you to write all the possibilities. Right. So next question. So next part of the question. The diagram is given here. Okay. Candidate may give the diagram first, and based on that decide if serial. Actually, that is what we did. Right? That is what we did. We first draw the diagram and we did it based on that because that is the easier approach. Okay. Right. Now, next one. Assume that each transaction will commit at the earliest possible point of time soon after completing the last transaction in the schedule given in 1 above. Now, the examiner has give you a hint. Assume that transaction will commit at the earliest possible point of time soon after completing its last transactions. Actually, it is not completing its last transactions. It should have been completing its last action. Okay, last action. So I think a little bit of ambiguity is there. So assume that when it has 3 steps or 4 steps, the moment your 4th task is done, it's committed. It's committed. So that is what the examiner is trying to tell. Okay. If the schedule was executed under 2-phase logging protocol, write down the logs acquired, release, or change. Okay. So change means usually upgrades and downgrades, but usually examiner is not worry too much about the downgrades and upgrades. I.e. release of SA to indicate release of shared lock for A, including any waiting for locks, commit or deadlocks at each of the time sharing starting at T1. Right? So you have to use this convention so that the examiner can easily see whether you have done it properly. Okay. So now do it. Now we read similar question. Now it's the same thing. It is the same schedule. Right. For this one, now you have to write down which locks are acquired at each level, which lock is released at level, and you have to write it in detail. Okay, in detail. Right, do it now. Do it. Now you know what to do. And assume that now this is write 1A, write 1B. Right, there are no write one operation. So you can assume that here the transaction one will be committed. So that is what the examiner is telling. Okay. So W3, no more W3. You can assume that after this step, transaction 3 is committed. At this step, transaction 2 is committed. Okay. And at this point, transaction 4 is committed. And the transaction 5 is committed here. So that is what is meant by at the last step, assume that it is committed. So, okay. So here the transaction 1 is committed because there are no transaction 1 operations. Here you can commit the transaction. Sorry, transaction 2 can be committed only here, right? Only here because there's another 2, right? So likewise, because in some other years, the examiner say that this is where the commit is, but here this examiner says at the last step, assume that that is your commit. Okay, now do it. Do it. It is the same transaction. Same transaction. You just have to write it. Use whatever the way you are convenient, but make sure you write in a proper way. Not too much details, but show it using some sort of a convention. Acquiring and release of locks and waiting. Release, acquire. You have to specifically say whether you are acquiring shared lock or exclusive lock. Whether you are releasing shared lock or exclusive lock. You are waiting for which lock? You have to say you're waiting for this lock. Okay, we'll do this. Okay, right. I hope you can undo it. So I need it again. I can use the other one. Okay. So I'm going to erase this. Right. So anyway, I don't need the dependencies for that part. Right. So how many resources are there? A, B, C, D, E. 5 resources are there. 5 resources are there. So the resources are A, B, C, D, E. Right. A, B, C, D, E. And each resource has shared and exclusive. Shared and exclusive. Shared and exclusive. shared and exclusive, shared and exclusive. Right. Step number 1, write A. So that write A. So there what will happen? Your transaction 1 will acquire exclusive A. Right. Exclusive A is acquired by transaction 1. Okay. Right. So that is write 1A. Okay. Write 1A. So then you have the read 1A. Read 2A. Transaction 2 need to read A. Now, can it read it? No, because exclusive lock is with the transaction 1. When you read, you look at the exclusive lock. If exclusive lock is available, you get the shared lock. But here, exclusive lock is not there because exclusive lock is with the transaction 1. So therefore, the transaction 2 is waiting for, but you are waiting for the shared lock. Right? You are waiting for shared lock, but you are looking at the exclusive lock, but you are waiting for shared day. Right? Shared day to acquire the shared day, but actually you are eyeing at the exclusive A, but what you need is the shared day. Right? Now write B. Write 2B. So that means the transaction 1 is going to get the exclusive B. Right? Exclusive B, because no one has taken the B. Now remember, exclusive A is with transaction 1. Exclusive B is also with transaction 1. Okay, transaction 1. Now this is done. This is done. And this guy is waiting. And now the examiner says at the end of the last step, assume that it can commit. Now that means committing. Right? Committing. So you can just say commit transaction 1 or commit transaction 1. So that means that now it can release both XA and XB. Right? So transaction 1 release exclusive A and exclusive B. You have to mention what is the notation you are using. I'm just using release, or you can just write release, acquire. Okay. Now both can be released. Now this is no longer there, no longer there. Okay. So that is end of this step. Now remember, the moment you release locks, the DBMS check whether any transaction is waiting for locks. Then before proceeding, those waiting transactions are notified. Now remember, the transaction 2 is waiting for shared day. Now earlier the exclusive A was given, now shared days can be taken because the exclusive A is now available. When exclusive A is available, shared day can be acquired. Okay, so therefore at the commit, another thing happened. Transaction 2 will get the shared day. Now shared day is with transaction 2. Right? Transaction 2. Now we can proceed. Now transaction 3 need exclusive 3. It's going to do the write C. Write C. So write C means now transaction 3 needs exclusive C. Of course, C is not used any still, first time you are using. Therefore, now transaction 3 get exclusive C. Transaction 3 has the exclusive C. Okay. Right. Now let's proceed. So now this is done. Now transaction 2 need to do read C. So this is transaction 3. Right. So transaction 2 need to read C. Transaction 2 need to read C. But now exclusive C is taken by transaction 3. Therefore, now transaction 2 has to wait. Transaction 2 waits for shared A, shared C, shared C. Because exclusive C is taken by transaction 3. Okay. So this guy is now this guy, the wait is no longer there. Now this is done, but now this guy is waiting here. Right? This guy is waiting here. Transaction 2 is unlucky transaction. It's always waiting for others. Right now, transaction 4 has to do read B. Right? Read for B. Right? Now B's lock is already released. Right? B was locked, but now it's released because of this commit. Okay. Therefore, it can get it. So therefore, transaction 4 will get shared B. Now transaction 4 has the shared B.
So excuse me.
Yes.
So එතන transaction 3 එක commit කරන්න නැද්ද?
Yes. Sorry for that. Yes, we can commit it, right? Because there's nothing else. Yes. Yeah. So I forgot that. So thank you. Okay. Yes, we can commit this because that is the last step. Yes. So the transaction 3 can be committed at this point. Okay. Commit. Okay. Let me delete these things. Right. Let me delete these things. Because that is the last step, we can commit transaction 3. Commit transaction 3. When you commit transaction 3, the transaction 3 can release the lock C. Okay, transaction 3 can release the transaction 3 was having the exclusive C. Now it can release exclusive 3. Okay, so now it's no longer taking this. Okay, no longer taking this. Right, now that is also done. Now we have to do the transaction to read C. Read to C. Transaction 2. Now transaction 2 can take the shared C. Shared C. Right, shared C. Transaction 2 has taken that. Okay, transaction 2 has taken that. Shared C. Now transaction, so this is done now. No waiting is needed. This is done. Now transaction 4 need read B. Read for B. Now check whether B lock is available. B lock was there, but B lock Wright lock was released. Right, and now it can take the shared lock of the B. Okay, because read lock is available. Read lock is available because the lock is already released. Right, so therefore transaction 4 read for B. Transaction 4 get shared B. Transaction 4 get shared B. Now the shared B is with the transaction 4. Shared C is with the transaction 2. Okay, transaction 2. Now that is also done. Now we need write D. So D is used for the first time, therefore no issue. Right? So that is transaction 1, right? Transaction 2. Write to D. That means transaction 2 get exclusive D. Now transaction 2 get exclusive D. Right, now write T is used for the first time. Right, that is T for W for E. Transaction 4 get exclusive E. Right, transaction 4.
Commit.
Sorry, commit can be done, right? Yes. So before that, let's commit it. Yes, I always forget the commit. Before that, let's do the commit. So we can commit the transaction 2 now. We can commit the transaction 2 now. Right, so let's commit the transaction 2. Commit transaction 2. So now if there are any locks held by transaction 2, we can release. So transaction 2 is keeping shared day, right? Transaction 2 release shared day. What else? Transaction 2 can release shared C also. Yes, shared C also it can release. Shared 2 also it can release. So shared C also it can release. Anything else? And also exclusive D. Exclusive D also it can release. Exclusive D, just it acquired, now it can release. Okay. Now basically these things are released. Okay. So now only transaction 4 has acquired the shared B. All the other locks are released. No one else is acquiring having any lock. Okay. Only the transaction 4 is having the shared B. Now write T transaction 4 write, that is write 4E. Write 4E. So that means transaction 4 will get exclusive V. Right? Transaction 4 will get exclusive V. Right? And we can do it. Okay. Now read the transaction 5. Now we can commit that also. Let's before moving to that, we can commit that. We can commit that. So that means it has to release transaction 4 commit. Commit transaction 4. So transaction 4 is going to release all the locks it's acquired. That is shared B, exclusive V. Right? Shared B, exclusive V. Now none of the locks are held. None of the locks are held. Now you can see that it can acquire the D, shared D. It can acquire the transaction 5 can acquire the exclusive V. Then again you can release those. So that so those we have to write. Okay, and then you are done. Right? Then you are done. So that is something you are expected to write. Okay, and now let's see the answer. Right. So here you can see it has acquired the exclusive way. It has acquired the exclusive way. Now the transaction 2 has to wait for the shared day because you are waiting for shared day. Okay. Now transaction 1 has taken the exclusive B. Right? Exclusive B. Now transaction 1 can commit. Okay, commit. That means you are releasing both exclusive A and exclusive B. Exclusive A and exclusive B. Okay. And when you release it, the transaction 2 is waiting for the shared day. Now transaction 2 can get that one. Okay, get that one. Now transaction 3 write C, so it get the exclusive C. Now transaction 3 can be committed. The transaction 3 commit transaction 3. Yes. So then it release and blah blah blah. You have to keep writing. Okay. So finally you get the shared B, exclusive V, and also you release those things. Okay. So here release of shared B and exclusive V. Shared B and exclusive V, and then acquire those two and release again. Okay. Right. I hope you can do it now. Okay. I hope you can do it now. So only thing is, when you are waiting for shared lock, when you are looking for shared lock, you have to check whether the exclusive lock is available. If someone has taken the exclusive lock, you don't get the shared lock. But when you are looking for the exclusive lock, you have to check whether both shared lock and exclusive lock is available. Okay. And whenever you release commit, you release all your locks. Forget about the lock downgrades and upgrades. Okay. assume that you are keeping both shared and exclusive. Okay. Fine. And look for the wording when the locks are going to be released. Otherwise, the examiner will say this is where the commit is happening. Okay. And so far, they have not given any questions on rollbacks. If rollback also, assume that you release all the locks, right? You release all the locks. Then you can go to the next point, next point, next point. Okay. Right. Right. Now we are moving to any questions? Otherwise, we can move on. Sorry? Yeah.
Do we have to write the answers in the same format as the answer?
Yeah, try to write it in the same format, but there's no hard and fast rule saying that you have to stick to with that. But use this notation, okay? Write 5E means fifth transaction doing the write. So this is exclusive lock is taken of the E. So you use that format, but the way you write the answer can be different. But try to use the same, the standard, so that the examiner can easily find out what is it. And also timestamp also, you can say this is the timestamp 1, 2, 3, something like that. It's not really a timestamp. So the next point, next point, next point, or you can just type say 1, 2, 3, 4, 5, 6. Okay. So there's no rule saying you have to stick to this, but now you can see this one is used in different way. When things are complicated, usually you have to go for this kind of a thing. But when things are simple, even the approach taken by last year or the 2020 is also good enough, because it was a very simple question. Then the examiner has taken a different approach. Okay, different approach, and also the examiners are also changing. So therefore, I can't say what is the best approach. As long as it is acceptable, readable, they will be giving you the marks. They have to give, right? So here you can see the examiner has taken much. Okay, so this one also pretty much similar approach. Okay, so when the question is difficult or complicated, go for this kind of a, actually this is the timestamp question, right? When the question is complicated, go for this kind of approach. Otherwise, you can just go for a simple approach as well. Okay, right? But as long as your answer is correct, you will be getting the, but don't make your examiner try hard to understand your writing style, right? So let's move on then. Any other questions? Because you can finish it by now itself. If you clarify all the things, then you can, right? You can do your extra time for other things. Okay. Otherwise, you will be spending a lot of time in the final year. Right. Okay. So now let's move on to the timestamp based transaction management. Right. Timestamp based. So some database management system prefer the timestamp based approach rather than log based approach. But the idea or the strategy is the same. There's a one-to-one mapping between the two tactics. So it's basically, if you have properly understood locking mechanism, you are in a very good position to understand the timestamp based approach. Okay. Actually, we are doing the same thing in two different ways, right? Two different ways using two different concepts. Earlier, we used the concept of blocking. Now we are going to use the concept of a timestamp. Okay, fine. So here the idea is, this is the main point you have to remember. Priority is given to the younger or more recently started transactions. If there's a competition for resources, say transaction 1 started somewhere here, transaction 2 started somewhere here. So transaction 2 is the younger one. It is the transaction that started later. So the priority is given to the younger transaction, not the older transaction. So this is different, right? So we say priority must be given to the older people, but in transaction handling, priority is given to the younger generation, right? Younger generation or the younger transactions. Older transactions are given low priority. Actually, older transactions have to roll back also, right? Okay, so that is the main idea. Keep this in mind. Keep this in mind. Priority is given to the younger, right, transactions that started later. Okay, right. So this is now here we have again few variations. So we will be first looking at basic timestamp ordering. Okay, basic timestamp ordering. Again, the strategy is much similar to log-based transaction. Right? So therefore, there's a one-to-one mapping. If you have properly understood log-based transaction handling, you are in a very good position to understand the timestamp-based handling. But you have to first understand the concept for the what we are going to do. Okay, right. So this approach is based on following 4 concepts. So first understand the 4 concepts, then you can understand the tactic. So there's a concept called timestamp of the transaction, right? Timestamp of a transaction. So timestamp of a transaction is the starting time of that transaction, because when a transaction start, the database keep track of what is that time. Say 10:34 maybe, and 500 or maybe 10 milliseconds, hour, second, millisecond, right? Something like that. Maybe another transaction start 10:34. So this is say 10 millisecond, say 15 millisecond. So that means this transaction is younger than this transaction. This transaction is older, right? So smallest timestamp means older, right? For example, if you have, if you born in 2000 and another one has born in 2002, now you can see this guy is the younger guy. Younger means bigger birthday, younger. Older means smaller date of birth. Same thing. Higher timestamp means younger transaction. Okay, so what is the timestamp of a transaction? When someone say timestamp of a transaction, it means the starting time of that transaction. The database management keep track of the timestamp of each and every transaction. So then we have the write timestamp of data item. So every data item has 2 timestamps. Just like every data record had 2 locks, read lock and write lock, or shared lock and exclusive lock. Every data record, data item has a write timestamp and the read timestamp. Okay. So this is the tricky one. What is this write timestamp and what is this read timestamp? So then there's a concept called commit bit. Each data item has a commit bit. So commit bit says whether the last transaction that access that data record has committed or not. So that is called commit bit. It's either 1 or 0. Okay. Right. So now let's take one by one. So the timestamp of a transaction is the starting time of a particular transaction. So that means every transaction has a timestamp. Okay, timestamp. And the younger one is having the higher timestamp comparing. Okay, right. So that is, I hope if you have any questions, then and there ask. Otherwise, those uncertainties will be accumulated and after sometimes it will burst out. Right. So next one is write timestamp of a data item. So every data item, every data record has 2 timestamp, read timestamp, write timestamp, and there's another third concept called commit bit. So those 3 are for the resource or record. The first concept is for a transaction, each transaction. Okay, right. So what is mean by write timestamp of a data item or data record or whatever? It is the timestamp of the youngest transaction that has executed write operation successfully on that resource. Okay, so it is not the last times this record is written. No. එහෙම තමයි ගොඩක් අය හිතන්නේ. loosely කියවන කට්ටිය. සමහරු කියවනවා නෙමෙයි තමන් හිතෙන දේවල් හිතා ගන්නවා කියවල ඉවර. තමන්ට හිතෙන දේවල්, තමන්ට ලේසි දේවල්. So pay a lot of attention. So right timestamp of a item X is the timestamp of the youngest transaction that has done the write operation. Write operation. Okay, for example, assume that this data item is written by two transactions, transaction 1 and transaction 2. Transaction 1 started at this particular point of time, say A times A. Transaction 2 started at B time. Now both has written. Now what is the right timestamp of A? Right timestamp of X. Right timestamp of X is what? Say this is time A, this is time B, this happens. Transaction 1 wrote at time C, transaction 2 wrote at time D. Transaction 1 started at time A, transaction 2 started at time B, and transaction 1 wrote X at time C, and transaction 2 wrote X at time D. Now what is the timestamp of right timestamp of X? That is the timestamp of the transaction, the youngest transaction that has done the write operation. So now both transaction 1 and 2 has done the write operation. The right timestamp of X is B. හරි මේක මේ time D වත් time C වත් නෙමෙයි. මේ transaction 2 ලිව්වේ D time එකේ කියලා D කියලා ගන්න බෑ. මෙයාගේ timestamp එක වෙන්නේ ඒ ලියපු youngest transaction එකේ transaction timestamp එක. So therefore it is B time. So that is very important. That is very, very important. It is not the time that transaction 2 written to X. No, it is the timestamp of the transaction 2, youngest transaction that has written. So therefore, right timestamp of X is actually B, time B. Okay, not time D. That is very important. Okay, right. So again, now read the question statement. The right timestamp of X is, it is the timestamp of the youngest having largest timestamp transaction that executed write operation successfully on resource X. It is not attempting. You must have successfully done that write operation. And its timestamp is the resource X write timestamp. So these timestamps are, resources timestamps are always timestamps of the transactions. They are not the time you read or write. No, they are, though we call it right timestamp, it is not the right time. It is the transaction starting time of that particular transaction or the youngest transaction. Okay. Right. So then how can you find the read timestamp? Well, these are the things that the database manage internally. Read timestamp of resource X. It is the timestamp of the youngest transaction that executed the read X successfully on resource X. That is again the read timestamp of X is the youngest timestamp of the youngest transaction that successfully execute a read operation on that resource. Again, the timestamp will be a timestamp of a transaction, not the time of the read operation is done. No. Okay. Right. So then what is commit bit? Commit bit is also related to the resource. It is set to true if the last transaction that has done write operation has committed. Say last transaction that did write operation is say transaction B. Still transaction B is not committed by this time. So that means the commit bit is false. The moment your transaction 2, because the transaction 2 is the one that did the last write operation, has committed, the commit bit of the resource become true because it's committed. Okay. So those are the 4 items: the timestamp of a transaction, write timestamp of a data item, read timestamp of a data item, and the commit bit of a data item. Right? I hope you can understand up to this point. If not, you have to ask questions and clarify. Clarify yourself. I'm here to help you. I'm not to confuse you. Okay. Right. Now what are the rules? What are the rules? When a transaction try to read a particular data item, when a transaction try to write a particular data item, what are the rules the database management system is going to check? And if the rules are satisfied, you can do the operation, read or write. If the rules are not satisfied, right? Rules are not satisfied. Now remember, in the previous approach, locking approach, if the rules are not satisfied, or if the lock is not available, you have to wait. This is sort of a very brutal approach. If the rules are not satisfied, right, you have to, or one of the transaction has to roll back, right? One of the transaction has to roll back. There's nothing called waiting here. This is very sort of a brutal approach, right? Amanshik approach. But the possibility of those rollbacks are very low, the way we do it. But yes, there's nothing called waiting here. Okay. Right. Now let's see what are the rules applied when it comes to you are doing a write operation. Now always look at the locking mechanism. Remember, when you come to write in locking, you have to check both read and write, or you can just say you have to check only write, because when someone is having write, no one is going to have the read. Okay, so though we say we have to check both read and write lock, right? Effectively, you just have to check whether it's write lock is taken, because if write lock is taken, no one else can take the read lock. Okay, so therefore here, when you want to do the write operation, okay, you have to check whether younger transaction has written or younger transaction has read X. It's just like you check whether someone has taken the write lock or read lock. මං කිව්වේ අර private වැඩේ කරන්න ආවට පස්සේ කෙනෙක් private වැඩේ කරන්න නැතුව ඉන්නත් ඕන. අනිත් වැඩේ ඇතුළේ ඇවිල්ලා ඉන්නත් බැහැ. මොකද දැන් ඒ මනුස්සයාට බේර. So you have to check whether both read and write when you come for the write. When you come for the read, you have to check only for write, because others doing the read is okay, right? So when you do write, you have to check both read and write. When you do read, you have to check only write. Right? Then we have read write to the analogies, right? So you have to check whether the younger transaction has written to X or younger transaction has read X. If younger transaction has written to X already, or if a younger transaction has read X, then you have to roll back. You have to roll back. Okay. Else you can do the write operation, because younger transaction has not read or younger transaction has not written. Now you can read it. You can write it. But when you write it, you have to make sure you update the write transaction of the resource. So you have to put your transaction type. If this particular transaction managed to write it, now the write transaction stamp of the X resource must be the starting time of this particular transaction. Okay, so we have to update that, and you are done. You are done. Now you did your write operation, and also you have updated the write timestamp of the resource X with your timestamp, your transaction starting time, not the time you did the write operation. Not, it is your transaction starting time is the write timestamp of the X resource now. Okay, because you are the youngest transaction that did the write operation. up to this point. Okay. Actually, no younger transaction has even read it. Because otherwise you have to roll back. Okay. So this is, in other words, you have to check whether your timestamp is smaller than write timestamp of this one, or your timestamp is smaller than the read timestamp of this one. So then you roll back because you are older. Younger කෙනෙක් read කරලා තියෙනවා, write කරලා තියෙනවා, එක write කරලා තියෙනවා, එක දෙකම කරලා තියෙනවා. Else you are the younger transaction that no younger transaction has read or write, then you can do the write operation and you update the write timestamp of the resource that you are done. Okay. Right. Any questions on that? That is how the write operation is done. There's two possibilities. Either you do it or you roll back. Right? Either you do write or you roll back. Okay. Because write operation is a serious operation. Now you do the read operation. Now look at the locking mechanism again. In locking mechanism, when you come to do the read operation, you only check the write lock. If write lock is not available, you wait. If write lock is available, you take the read lock. Write lock is available means write lock is not taken. Now you take the read lock. That's it, right? Now let's see what is happening in timestamp based approach. Right? Now the transaction T needs to read the item X. Now remember, when you read, you check the write lock. Same thing. You check the write timestamp of the resource. If a younger transaction has written to it, you roll back. You roll back. If a younger transaction has written to it, you roll back. Else, that means a younger transaction has not written to that resource. So now you can read it. Now you can read it. But whenever you read it, you have to make sure you update the read timestamp of the resource. And value write timestamp, update read timestamp. Right? And here there's a little bit of complication. Now you check the write timestamp, okay, before reading. Now you can't just update the read timestamp with your timestamp. No, you can't do that. Now you have to look at the read timestamp of the resource. If a younger transaction has read it than you, younger transaction has read it, not written, okay, then you don't have to update the transaction read timestamp. Right? You can read it, but you don't have to update the read timestamp. But if you are the youngest transaction that has read now, right, that means your timestamp is bigger than the given read timestamp. Now you have to update the read timestamp of the resource with your timestamp after reading. That's it. Right? If T is younger than the youngest transaction that has read X, then timestamp of T is set to the read timestamp of X. T is timestamp of T is set to the read timestamp of X. Otherwise, you don't do anything here. But still you read it, but you don't update the timestamp because the timestamp must be with the youngest one. You are not the youngest one. So therefore, you read it, but you don't update the timestamp. That's it. Okay, that's it. In other words, you check if your timestamp is smaller than the write timestamp of the resource, that means younger transaction has written, you roll back. Otherwise, you do it. But again, check whether your timestamp is bigger than the read timestamp, then you write it. Otherwise, you don't write the change the timestamp of the read timestamp of the resource. Okay. So it is max of your the available read timestamp and your timestamp is written here. If your one is bigger, yes, you update it. Otherwise, keep the older timestamp as it is, as the read timestamp of the resource. Right, so that's it. ඔන්න ඔය දෙක තේරෙන්න ඕන. ඔන්න ඔය දෙක තේරෙන්න ඕන. හරි. So that is how the timestamp ordering transaction handling work. Okay, so then there's another one called Thomas Wright rule. So we'll look at it later. Somehow you have to understand this, and somehow you have to remember that also. Not only understand that, you have to remember that also. So I'm just going to help you remember this now, right? So I don't take it bad sense that I'm giving you dirty jokes, right? So I took the analogy of a washroom. I know it's a dirty example, but I cannot find a better example for that. That is why I gave you that example, because somehow you have to remember it as well. So I'm going to give a dirty example like that here also, just for your for the sake of you to easily remember this. Right? Otherwise, I don't do that kind of things in the classes. Okay, this is the final year and critical that you remember this as well in the exam. Okay, so it's something like that. Say, assume that there are girls and boys. Okay, so read operation is something like a boy asking from a girl. Right? Boy can කැමතිද කියලා අහන්න එනවා. කැමතිද කියලා අහන්න විතර වෙනකුත් කරන්න යා. So then what it does, the boy do, it check whether younger, එයාට වැඩිය වයසින් අඩු කෙනෙක් මේ ගෑනු ළමයාට මොනාරි උටපටයක් කරලාද කියලා check කරනවා. කරලාද කියලා අහලා නෙමෙයි යා. කරලාද කියලා check කරනවා. එහෙම කරලා නම් මෙයා roll back වෙනවා. මොකද මේක අයිති අලුත් generation එකට කියලා එයා roll back වෙනවා යනවා යන්න. Right? That's it. හැබැයි එහෙම නැත්තම් ඒ කියන්නේ යාට වැඩි අංග කෙනෙක් මේ ගෑනු ළමයාත් එක්ක කිසිම උටපටයක් කරලාගෙන නැහැ. Then මෙයා අහනවා විතරයි යා. It does the read operation. කැමතිද කියලා අහනවා. අහලි වෙලා එයාගේ time stamp එක දාලා යනවා. එයාට වැඩි young අය අහලා තියෙනවනේ හැබැයි දාන්නේ නැහැ. හරි එයාට වැඩි young අය අහලා තියෙනවනේ දාන්නේ නැහැ. නැත්තම් එයාගේ time stamp එක දාලා තියෙන මම තමයි අඩුම වයස් බාලම වයස එක්කෙනා මෙයාගෙන් අහලා ගිය එක්කෙනා කියලා. So that is what the read operation. But write operation is more critical. So you check whether a younger transaction has read or written. Dekam බලනවා දැන්. Because you come to write. If a younger person has asked or do something to this girl, you roll back. Otherwise, you do that operation and you update the timestamp as I am the youngest person guy that has did something to this. Okay, Kira, timestamp ek gala. So it is something like that, right? So in Wright, you again the idea is younger people are given the or younger transactions are given the priority. All the transactions have the lesser priority. Okay, so that is why you are always looking for the timestamp. Okay, but in read, you look at only the write timestamp. In write, you look both read and write timestamp. In write, you update the write timestamp. In read, you update the read timestamp. In write, you always update the write timestamp, but in read, you update only if you are younger than the other transaction that has read. Right? It is not always you are updating the timestamp, but write, you always update the timestamp. Okay, something like that. Okay, right. Now we have one more rule to add, that is Thomas Wright rule. Thomas Wright rule. So what is that? So the Thomas Wright rule says, if a younger transaction has already written the value of an object, then less recent transaction does not need, the less recent means older transaction, right? If a younger transaction has already written to that record, that resource, if you come to write, if the other transaction come to write that resource, you don't have to do your write. You don't have to do your write. You can just ignore writing and proceed with your other tasks. You don't have to do anything. You don't have to change the timestamp and you don't have to do the write. So you come to write the value, update the value, but you don't update it. You just think that you have written it and you proceed with other tasks. So that is what Thomas Wright rule says. Right? Thomas Wright rule says. Okay. Because the idea is, now you are old transaction. Right? You are older transaction and say you are T1. T2 started later and T2 has already written to X resource before you. Now you try to write to the X resource. Right? Now, no point you writing it because a young transaction that started later is anyway supposed to write to it. And you are older one. So therefore you can ignore it because if you have written to it, right, or already the younger transaction is supposed to overwrite it because this is the younger one started later. So therefore you don't have to do this now because anyway, if you do this anyway, this should have been this would have been overwritten because this guy is the younger. This guy has the more priority because later transaction has the authority to override the values of all the transactions. So therefore you just ignore it, right? You just ignore your write operation and you proceed. You don't do anything, right? So that is what Thomas Wright rule says because it doesn't violate any business rules. Okay. So that is what Thomas Wright rule is. If a younger transaction has read X, so then this is after the Thomas rule is applied. Okay. So here, if the younger transaction has written, you skip the write operation. If not only, you do your write operation and update the timestamp. Okay, so therefore this one is now updated. Earlier it is you always write it, but now you check whether the younger transaction has written to it, then you don't do your task, your write operation and proceed. Otherwise, only you do the write operation and update the timestamp. Okay, right. So that is when Thomas Wright rule is also incorporated to the write operation. It is not going to change the read operation. It is going to change the write operation after Thomas Wright rule is applied. Okay. Right. Now, like we can do a question on timestamp ordering as well. Okay, let's do a past paper question. Right, timestamp ordering is little bit complicated to remember. Locking is much more easier to remember. This is, I can't say this is difficult to understand, but little bit difficult to remember. So that is why you need some sort of analogy, stories to remember it. Okay, right. So let's do past paper question. Timestamp questions are fussy. Sometimes answers are also a little bit conflicting. Right? Right. Assume that the concurrency control is done using timestamp ordering, timestamping protocol. And all the timestamps are initialized to 0. The timestamp based scheduler will allocate timestamp for the transactions using counter starting at 1. So rather than timestamp as 10, 10, 2, 10, 3, 10, 4, just assume it's a counter because that is enough. We don't need the exact timestamp. What we need is which one happens before or which one is younger, which one is older. Therefore, we don't need the exact timestamp. What we need is to check which one happens before this or what, whether this happened before that or after that. right? So therefore, numbering like 1, 2, 3, 4 is good enough, because then we know that 4 is younger than 3 and 7 is younger than 2, right? So that's it. You don't need exact timestamp. Okay, so that is why it's a, you just assume that transaction using a counter starting at 1. You can say this is timestamp 1, 2, 3, 4, 5, 6, 7, 8. Right? Time unit 1, time unit 2. That is good enough for you. Okay, it's good enough to. It's perfectly okay. You don't need exact timestamp, and you don't need the exact time difference. Okay. Clearly indicate the timestamp of T1 and T2 and read the right timestamp. So you have to mention what is the timestamp of T1, what is the timestamp of T2, that's the timestamp of the transactions, then the read timestamp of A, write timestamp of A. And here it's easier because you have only one resource. It's very easy question. I thought at least there are 2 resources. No, just one resource. Right? Clearly indicate the timestamp of T1, T2 and read and write timestamp of X at each step until both T1 and T2 get committed. Right? So let's do it, because this is the first time we are doing it. I hope the question is now understood. Right? Question is now understood. So when it comes to timestamp questions, they don't give you very complicated transactions, because students get easily confused because so many concepts are there. Right. Now, so the time, now the transaction 1 starts. Okay. Transaction 1 start. So let's say this is my transaction 1 start here. Say it is time unit 1. Okay. Now, they are the transaction 2. They have not mentioned exactly where it starts, but we can assume that it is when the first activity is happening. Okay, first activity is happening. Okay, so therefore, now let's say read day. It happens in the time unit 2. Okay, read 1A. Now, what is now? Of course, the A has no timestamp. A has not been read or written. Nothing has happened to A. A is a fresh resource. So obviously transaction 1 can do the read operation. But now your A is going to have the timestamp as 1, because that is the starting timestamp of transaction 1. Right? Starting timestamp of transaction 1. That is read timestamp of A. Right? Here, read timestamp of A is 1 now. Okay, so it has 2 timestamp, read timestamp, write timestamp. Now the read timestamp is 1. Okay, now transaction 2 starts. Okay, timestamp transaction 2 start. Okay, so this is, let's say this is 3rd times slot the transaction 2 starts, and its timestamp is, let's say, 3. Okay, now it needs to read day. Right, now it need to read day. How do you read? You look at the right timestamp of A. Right, බලන්න මතකයි නේද? right timestamp එක තමයි බලන්න. දැන් right timestamp එක විදිහට දින අපි හිතමු බිංදුව හරි නැත්නම් අපි හිතමු බිංදුව කියලා. හරි, පටන් ගන්න දෝන නම් හිතන්න පුළුවන් බිංදුව තියුනේ කියලා. බිංදුව. Right, now your timestamp is 3. You are younger. The right timestamp is say 0 or something. Okay, so actually no one has written to it. When you write, you look at the, when you read, you look at the right timestamp. Right, you are younger, because right timestamp is still 0, because this guy did a read operation, not a write operation. So you check the right timestamp. Okay, look at the note again. The younger transaction has written to it, so you roll back. Otherwise, you read it. Right? Otherwise, you read it. Right? So no younger transaction has written to it. Actually, no one has written to it. So therefore, you can read it. Right? You can read it. Right? Now you did this, you did this. Okay. So transaction, now let's say fourth time you need the transaction 2 read day. Read day. When you read day, what you have to do? You have to update the read transaction time. If you are the younger, you have to update it with your transaction time. If you are not a younger one, you just keep the read transaction. Now you are a younger transaction. So therefore, read transaction time RTSA is now 3, because your transaction time is 3. Now this is not 1, it is 3. Read timestamp is 3 according to our convention. Okay, because that is where the transaction 2 start. Transaction 2 has read it. The timestamp of the transaction 2 is the read timestamp of A now. Now A is doing some task. Okay, so it's not related to us because it's not a read or write operation. Okay, so let's not have a timestamp for that. If you want, you can just say 5. It doesn't matter. Now we are writing A. Now remember, when you're writing, you have to look at both read and write. Right? You have to look at both read and write. If a younger transaction has read, you can't write. Right? You can't write. If a younger transaction has written, you can write. You don't have to write. You can just proceed according to Thomas rule. Okay. Look at the logic again. So write. If a younger transaction has read, you have to roll back. Now you can see younger transaction has read A. Right? So therefore, what we have to do? You have to roll back. Say this is your 5th times unit. You try to write A, and younger transaction has read it because its timestamp is 3 now. Right? Your timestamp is 1. So therefore, now you have to roll back. Okay, so let's see if the answer says that. Yes, you have to roll back. Okay, you have to roll back. Cannot perform. Okay, you have to roll back. Now what will happen? Now this is not failed. This is failed actually. Roll back. Now transaction 2 has to do a particular operation now. Of course, that you can do because you have already read it. Right? And now transaction 2 has to write. Right? Transaction 2 has to write. Now it's okay because you are the younger guy who had read. Your transaction time is there, and no one has written it because this guy rolled back. Now you can write it. Now you can write it. Right? You can write it, and you have to update the write timestamp as the timestamp of T2. Timestamp of T2, because it is your timestamp now. The write timestamp is your timestamp. Now the read timestamp is also 3. Write timestamp is also 3 after this point. Okay, after this point. Now, of course, this is not committed because it's rolled back already. Now you can commit. Now transaction 2 can commit. Now when the transaction 2 commit, the transaction 1 has to again restart. Right? Now when you restart, you should be able to proceed. Okay. Right. Now let's see the model answer. So assume, so they say transaction 1 started at 0. So why they say transaction 2 also started at 0? I don't know why they mention like that. Okay. Anyway, so now reading resource A. Okay. So that can be done. Okay, that can be done. So the read timestamp of X is now 1. Why they are taking it as 1? This is a little bit confusing.
So එතන question එකේ කියනවා නේද all the timestamps are initialized to 0 කියලා.
Yes, that is initially. That is initially, but transaction 2, that means both are started at the same time. Question is not very clear. If both, does it mean that both transactions started at the same time? There's nothing called two transactions starting at the same time. Okay. Assume that the concurrency control is done using timestamp protocol and all the timestamps are initialized to 0. That is initialized. Okay, that is fine. The timestamp based scheduler. Okay. Maybe they have taken transaction 1's timestamp as 1. Okay, timestamp 1 as 1. Because that is the first, this is the time where you do your first operation. I think that is fair. Okay, that is fair. Okay, let's say that is okay. Right, now the timestamp 1 is 1. Transaction 1 started at the timestamp 1, and that is the timestamp of the read timestamp of X as well. Okay, so let's say that is okay. That is not issue, right? So there is no conflict there. There's no conflict there. So the examiner is using different sort of a convention. Okay, so now the transaction 1 started at time unit 1, and at that time unit it is reading A because no one has read it. You managed to do it. Now your read timestamp of X is 1. Of course, the write timestamp is still, you can consider it as 0. That is fine. Okay. So they are initializing everything to 0. Therefore, the timestamp of 2 is 0. That is also fine. Okay. Right. Now, transaction 2 read date. Now that is read 2A. Still the transaction 1 timestamp is 1. And this is the timestamp where the transaction 2 start. So they have taken this as T1. So the time 1, 2, 3, etc. So therefore the transaction 2 start at second time unit. That is fine. And also now we are doing another, now you are a younger transaction, therefore you can read it and you have to update the timestamp of the X as read timestamp as 2. Still the write timestamp is 0. That is okay, right? That is okay. Now you are doing operation. When you are doing operation, you don't have to change the timestamps, right? Still the timestamp of 1. Anyway, timestamp of the transaction will never change, right? Now it is always 1 and 2. You can see 1 and 2. So this is not changed anyway. The read time, write timestamps are also not changed because it's not a read or write operation. It's not a read or write operation. Okay, so can you understand up to this point? Let's stick with the examiner's notation. Right, now you are writing A, right? Writing A. Okay, write A cannot perform. Why? Okay, write A. Right, yes. Now you are trying to write A. Now when you are writing, you are checking both read and write timestamp of X. If a younger transaction has read or written, you can't do it. Now you can see that your timestamp is 1, but the read timestamp of the X is 2. That means younger transaction has read it. Younger transaction has read it. Now you try to write it. No, you can't write it. You can't write it. You have to roll back. I hope that also understandable. Okay. You roll back. Okay. Now the other transaction is doing A plus 10. Doing A plus 10. So that is fine. That is fine. Still the transaction timestamps have not changed. Right? And these things are not changed because it's not a database operation. It's a calculation. Okay. Now the transaction 2 write to A. transaction timestamps are the same. Now, when you write, you have to check whether younger transaction has read or written, right? You are the younger transaction anyway, so therefore you can do it. You can do it. So therefore, you are not changing the read timestamp, but now you did it. You are now updating the write timestamp with your one. So if you do a write, always you can update with your one, no issue. It is when you do read only, you check whether a younger one has read it, then you keep it. Otherwise, you update. Here, always you can update. I hope that is also understandable. Okay. And now the transaction 2 is over. Transaction 2 is over. Now T1 start with new timestamp. So that is very important. Now again, the transaction 1 has to start. Okay. With a new timestamp. ඔන්න එයා දැන් younger කෙනෙක් වගේ පටන් ගන්න හදන්නේ. ඉස්සෙල්ලා younger කෙනෙක්ට පෙරදුනානේ. දැන් මෙයා ආයි නෑ මම old නෙමෙයි මම දැන් තමයි පටන් ගන්න කියලා එනවා ආපහු. Resources ගන්න. Right. Now again it has to do the start from beginning. Start from beginning. Now the transaction of the timestamp of the T1 is 3. T2 is not changed. Right. Now, when you read, you check both read and write timestamp. Sorry, you check only the write timestamp. Okay, write timestamp. Now, your timestamp is 3. The write timestamp is 2. Right? Write timestamp is 2 because that is the transaction time of the transaction 2. So now you are younger. You can do the read because your timestamp is 3. Bigger means younger, right? Write timestamp is 2. You can read it. When you read, if you are the younger one, you have to update the read timestamp. Earlier, the read timestamp was 2, but now you are the younger one, so you have to update the read timestamp with your one. Write timestamp is not changed. Okay. Now this is an operation. Nothing is going to change. Nothing is going to change. All values are still there. Now you have to write. Right now you have to write. Your timestamps are not changed. When you write, you have to check whether the younger transaction has read it. If a younger transaction has read it, you can't write it. Or younger transaction has written it. If a younger transaction has written it, you can ignore it as well. Now, what is the right? What is the your timestamp is 3. You are anyway younger, and it is your timestamp is in the read also. Write is older one, right? Older one has written. Now you are younger again because you started with timestamp 3. Yes, you are the youngest one right now, so therefore you can do the write. And when you do the write, of course, the read timestamp is not changed because you are doing a write operation. You have to update the write timestamp with your timestamp. Right, write timestamp with your timestamp, and you are done. You are done. Okay. So that is how it. I think the examiner has explained it better than me. Right? Better than me, and that is how you proceed. Now you can see that this transaction had to once roll back and again start after transaction 2. Actually, the end user will not see it. End user will see a little bit of a delay only. Right, delay only. So therefore, don't think that someone is getting error messages. No, you roll back and with a new timestamp, you again start because the younger guy has younger transaction has කොක්කදම මැදදී. ආයි එන්නේ අලුත් younger කෙනෙක් වගේ තමයි ආයි එන්නේ දැන්. ආයි එන්නේ අලුත් transaction එකක් වගේ තමයි එන්නේ. තුමේ current timestamp එකෙන් නෙමෙයි දැන් එන්නේ. So now your timestamp is T3. Your transaction 1's timestamp is T3. Or the new restarting time. Okay. Right. So I hope you got it. And here you don't have to use the youngest rule. So the Thomas rule එක මොකද younger කෙනෙක් ලියලා තියුන්නේ නැහැ. මොකද ඔයා මෙතන පටන් ගන්නකොට ඔයා තමයි දැන් ආයි younger. හරි. නැතු හිතන්නේ මම T2 write කරපුවාම මම ලියන්න ඕනේ නැහැ කියලා නෑ. ඔයා දැන් අලුතෙන් පටන් ගන්නකොට ඔයා අලුතෙන් යන්න කෙනෙක්. ඒක හන්ද ඔයාට වඩා යම් කෙනෙක් ලියලා නැති හන්ද ඔයාට මේක ලියලා තමයි time stamp එක update කරන්නේ. Okay. So that is how it is done. So any questions? Any questions? If you cannot understand any of these steps, you have to ask any of these. Why this is changed? Why this is not changed? Blah blah blah. Why it is done like that? Why it is not like that? Done like that? So I'm here to explain you.
Sir.
Yes.
Restarting from T1, I couldn't understand. Yeah, from there.
T1 restarting.
Yeah.
Yeah. Now remember
After
T1 had to roll back. Okay. That you can understand because the younger transaction has read it. You cannot do the writing. So therefore you had to roll back. That you can you understand?
Yes, sir.
Okay. Now if you
Yes.
roll back, you have to restart again. Right? If a transaction is rolled back, the transaction has to again restart. So that restart is not going to happen immediately. Right? So that restart is going to happen only when the other transaction is committed, because now it knows, the database knows why this transaction is rolled back, because of the transaction 2. Because of the transaction 2, the younger transaction 2 has done an operation. Now immediately, now database is keeping track of what is the reason for transaction 1 to roll back. It is transaction 2. Now when the transaction 2 commit, database immediately restart the transaction 1, because it knows that because of the transaction 2's conflict, this transaction 1 was rolled back. Now the transaction 2 is, the younger transaction is finished, committed. Now you are starting the transaction 1. The database again restart the transaction 1, but as a new fresh transaction. So therefore transaction 1 get a fresh big new timestamp. Still it is, are you confused? So now it is clear?
Okay.
Okay. So if it is rollback, we have to restart. But database is not going to immediately restart, because it knows this guy was rolled back because of this transaction. So it wait until that transaction is finished. Then restart. And also when you restart, you get a fresh timestamp. So therefore now you are a younger transaction, because you are starting again from as a fresh. Okay. And also when you start fresh, if there's another transaction 3 has also started somewhere, maybe you will have to again roll back. Right? Again roll back, and things can happen. Things can happen. Say you again start here, and again after you start, another one start, and when you come to do the write, the other one has also read. Now again you have to roll back. Right? So that can happen. Right? Because you restart, after you restart and doing the read, another one read. Now again you come to write, and another maybe transaction 4 has read it again. Again you have to roll back. Okay, unfortunately that can happen. Then again it will be restarted after this transaction 4 is committed. Right? So after sometimes anyway you will be getting an opportunity. Okay. So these transaction conflicts are very rare, very rare, because it's very rare that 2 transactions work with the same record. But it is rare means we can't ignore it. If it happens in a very rare situation, still we have to handle it. So therefore don't think that these rollbacks are very frequent, but it can happen. So that is because it's part and parcel of our tactic strategy. Okay. Right. Any other questions? It's a good question, because maybe your confusion is how does database know when to restart? Yes, database know the restart must be done once your competitor is done. Right? Your conflict in transaction is finished, then only you will be restarted, because database is keeping track of all those things. Okay. Right. So let's see whether there are any other timestamp based questions. So timestamp based questions are always fuzzy, interesting, challenging. Okay, we'll finish all the transaction questions. Then the topic will be over, right? Otherwise, we are just keeping here and there, right? So let's see whether we have the 2020 past paper. Let me check whether we have the 2020 past paper in the VLD. Semester 6. What is the subject number? What is the subject number? 6405. Okay, so let's do the third question. I hope we didn't do this 2020 paper. We'll finish the transaction question other than recovery. Okay, so then the topic will be fully over once the recovery is done. Right, so question 3A. Right, question 3A. Or we can do something like this. So we have another session in the evening. So in the evening, I am going to do the past papers and finish this. So then you have the time. Otherwise, I'm taking that opportunity. So make sure you do 3A. Okay, you can mark it. Okay, make sure you do. You can just take a pen and mark it. Finish the transaction topic today itself. Then you don't have to worry, right? So do 3A, 3B, 3B, 3C. Don't look at the answers. You are not kids. Okay. 3D. You can now do it. It's a timestamp question. Don't do 3. Don't do 3 because 3 we haven't done it. Okay. Right. So that means question 3. Okay. Question 3. Okay. Okay. You can do all the database transaction questions. Now I'm going to do the recovery part as well. So therefore I will do the recovery part as well. And in the evening, I will be doing all the past paper questions. So now you can see there's a full question on transaction every year. You have to make sure that you have done those transaction questions by evening. Okay, by evening before 7 o'clock. Right. So let's finish the. Then in the evening, I will be doing those questions. And if we have time, we will be doing the distributed databases. Okay. So then we have to do some questions on query optimization. And don't worry, this topic on triggers and stored procedures, that is the easiest one. Okay. So I'm doing the fuzziest one first so that you have time to think. Right. So let's finish the transaction topic. Then you can take all the transaction questions, do it before evening. Okay. Right. So any questions on timestamp approach? Right. So what we discussed was the basic timestamp ordering. Right. Basic timestamp ordering. So there's a variation of this approach called strict timestamp ordering. Right. Strict timestamp ordering. The only difference is, remember we discussed another concept called commit bit, but which we never use it, right? Commit bit. The commit bits keep track of whether the last transaction that's written to it has committed or not. Okay, committed or not. Now remember we discussed something called the irrecoverable schedules and the cascade rollback. Okay, especially the irrecoverable schedule. Say you do it, some other transaction has written to it, and you read it, and you finish your transaction and you commit it. Now this guy roll back. Now it's irrecoverable because you have committed with that read value, but this guy has now rolled back. So in order to prevent this issue of irrecoverable schedules, we can use that commit bit as well. Right? Commit bit as well. In that case, if the commit bit is false, that means commit bit is false means the last transaction that written to that has not committed yet. We can delay the read and write operation, both read and write operations, right? Until the commit bit is 1 or that transaction has committed. Then only we do the read or write operations and update the timestamp of the resource. So then we say it's a strict timestamp ordering. When you go for strict timestamp ordering, that irrecoverable schedule issue is no longer there. But in the exam, unless they have never mentioned about strict timestamp ordering in the questions. So you can always assume that you are not considering the commit bit. But if the commit bit is needed, they will explain that. They will tell that this is where the commit is happening, blah, blah, blah. Okay. So otherwise, so far, we never had to use the commit bit. Okay. So you can just assume that it is basic timestamp ordering unless they mention it. Okay. Right. Right. So I told you that the login system and the timestamp system is two most popular approaches. And out of that, most databases now tend to use the timestamp ordering approach. There are some other approaches as well. Right? The databases have tried out, and you know that the most complicated software is operating system. Right? That obviously. And you know Linux operating system, the Unix operating system is evolved from 1950s, 60s, right? And the Mac operating system has developed separately. The Windows has separated mention, and those are the two big companies in the world, right? Apple and Microsoft, because they have the operating system. Now you can see that if you have operating system, you are a big guy in the world, right? Bill Gates, Microsoft, right? Apple, right? Mac operating system. So who is the guy who died a few years ago? I can't remember. Steve Jobs, right? So big people. Then Google. So they have the Android. So Google is sort of a big guy, right? So now you can see all of a sudden the Chinese, Huawei is no longer there. Huawei phones are kicked out. Why? They were banned using Android, and they were asked, okay, you develop your own operating system and you do it, sell your mobile phones. Now all of a sudden no one is caring about Huawei, though their hardware level, it's a superb phone. So the second most complicated software is database, right? Again, Microsoft has the database, right? Bill Gates. So then the Oracle. So that guy is also in the top 10 millionaires. And the top 10 millionaires like list or no, Oracle in no. Top billionaires. Because it's very difficult to develop a database. Right? So who's that person? Jeff Bezos. So Jeff Bezos is from where? Oracle. So not Jeff Bezos. Who is the other guy?
Jeff Bezos is Amazon's owner.
Yeah. So who is the data Oracle guy? I think he's in the fifth position. No. Larry Ellison. So he's from Oracle. So they are why the two most complicated softwares are one, operating systems, second, database. Okay, so therefore databases use different techniques. So the third technique is, and also we have small databases as well, like the Microsoft Access and base, and small systems like DBase and other things, right? So some databases use, or they have tried at least, optimistic concurrency control schema. So what is optimistic concurrency schema? So we don't have to go into details, but just we have to aware that this mechanism is also there. So there what they do is optimistic. You know what is mean by optimistic? Subhavadi. Pessimistic, optimistic. So positive, negative. So optimistic means we assume that things will end well. Pessimistic means we always assume that things are going to end up in negative way. The possibilities there. But in optimistic, what we do is we do the transaction first without worrying about locking or other things. Okay. No checking is done while the transaction is executed. But at the end of the execution, we validate whether we have violated any of the issues, so the serializability issues. If it is not violated, we commit it. If we find that it has violated, because violation can happen very rarely, right? 99.9999% of the time, violation, there won't be any violation. So therefore, we do it first, then we check the violation, and if violation is done, we roll back and then restart. Okay, so that is the idea behind optimistic concurrency control. And anyway, you have to check it, but we are not doing the checking and proceed. Rather, we proceed and then we check the if there are violations. So that is called optimistic concurrency control. Okay, so both has its own pros and cons. Right, now we are moving to our final topic, right? Recovery from failures. So remember, one of the important aspect of transaction handling is if a database fail, because database can fail due to various reasons, right? So hardware issues, software issues, right? Maybe virus attack, or maybe corruption of your operating systems all of a sudden get issues, or maybe resource issue, memory issue, or something like this, or processor issue, and your computer get hang, because those things can happen in a production environment because a lot of transactions are happening. So in case of a sudden failure, we must be able to recover that transactions that was happening middle way, right? And there are some more complications. Maybe transaction is committed, still it is not flushed to the data files. Maybe transaction was not committed yet, but already the data is flushed to the files. All these possibilities are there. And we want to make sure that not only the committed transactions are recovered, the uncommitted transactions are also recovered. Recovered in the sense we put it into a stable situation. So that is a very challenging job for the database software. It is not a challenging job for us. It is a challenging job for those who are developing databases like Oracle, Microsoft SQL, MySQL, etc. Okay, right. So how can we do the recovery? Actually, recovery is not done by developers or database administrators. The recovery is sort of automatically happen, and we get a report saying these transactions are recovered. Up to this point, transactions are recovered. From this point onward, transactions are not recovered. And usually there won't be any conflicts. So there won't be situations if the recovery is properly done by the database management system. There won't be situation saying that, okay, this transaction is half done. No, either transaction is committed or transaction is rolled back. Right? So there won't be a situation where transaction is half done and please do the needful. No, nothing like that. Okay. So you will get list of transactions committed, list of transaction rollback. So the rollback transaction, you have to manually redo it, or you have to inform the customers that, okay, because of our failure, this transaction was aborted. You have to do your transaction again. Okay. Right. So how to do this? Right. How does database do this recovery in a very skillful or smooth manner so that no conflicts are there? Right. It's again a long story, long and complicated story. Okay. Right. So this is what happens. From time to time, your database management system do something called checkpoints. Time to time, it depends on the criticality of the database and other things, and how often you do the transactions. It takes checkpoints. Okay. And also, before doing any transaction, commit to the files, data files, your database always write it to a log file called transaction log. Right. So it first write to the transaction log and then do the read and write operation of the file. So therefore, all the read and write operations are written to the transaction log. Okay, just give me 1 minute. Okay, sorry. So whenever you write or do a database operation, read or write operation, before doing it to your data files or index files, always it is written to the transaction log in a specific format. So then only it does the real writing or reading from the data files. Okay, so that is number one. Right, number one. The number two is time to time it take the checkpoints. When a checkpoint is done, again you write it to the transaction log saying a checkpoint is done at this particular timestamp. Okay, so therefore your transaction log will have all the read operations, write operations, right? The commit operations as well as checkpoint operations, saying that this particular time checkpoint is taken. Checkpoint, or sometimes we call it save point. Okay. Right. So what is happening at a checkpoints? What is happening at a checkpoint? So first, it suspend all the transactions temporarily. Halt, not roll back or something. They halt all the transactions. Something like freezing, right? For a very small time movement. Then it force or flush any modified values in buffers to the disk, because sometimes maybe some data in the memory, dirty record, which you have not written to the disk, because accessing disk is a costly operation, time taking. So therefore, sometimes your DBMS keep those data in the memory until for some time period. If it is again updated, right? So then only you are going to write it. Rather than you access the file 3 times, you are just waiting for that record to be updated again and again, and then only you write to the file. And also sometimes when you are having a page file, remember from the disk you take it to the page, the memory page. So maybe another transaction will change another record, another transaction will change another record. Then after sometimes you write the page back, flush it, so that all these are happening at the same time, because accessing disk is costly operation, time consuming, and also both processor and disk resource is utilized. So therefore, when you are taking the checkpoints, any of these memory buffers will be flushed to this file or SSD or the thing. So freeze every transaction, flush it. Then you write a checkpoint to the transaction log saying we took a checkpoints at this particular time. Then it resume the transaction. Resume means from where you stop, now you proceed. So this happens periodically, maybe after every 10 minutes or every 15 minutes. Okay. So this will happen. And in addition to that, there will be backup. This is not a backup operation, so don't get confused. Right? A lot of confusions are there. So this is something database do time to time. This is not taking backups. And taking backup is separately happening. And sometimes you can take a backup at a checkpoints as well. Right? Backup, or sometimes you don't need that kind of backup, because when you go for raids, there's a live backup also, because same data is written to multiple disks. When one disk fail from other disks, you can recover it. Actually, the database is recovering in the background. You just replace the failed disk, and again, though it's failed, those data is available in other disks. So therefore, your database won't feel any harm, and your database is going to again restore the new disk once you replace the hardware. So there are so many possibilities. Okay, so that is why in a banking applications, etc., very rarely the bank say that we have issue in your transaction. Okay, these days, not all days, these days things are very sophisticated. Okay, right. I hope now you know what is meant by checkpoints. Okay, and what is happening. Right, now we are going to discuss about how these log entries, so the transaction log entries, what is the format of it. Again, you have timestamp, right? Timestamp or just 1, 2, 3, 4, because exact time is also important when it comes to recovery, but at least you need 1, 2, 3 timestamp. Okay, so then every time a transaction does a read or write operation, you mention which transaction, which data item, whether it's a read operation or write operation. Then very important, you have the before image and after image. What is the value before the operation? What is the value after operation? If it is a read operation, both are always same. Right? Always same if it is a read operation. But if it is a write operation, this is the old value, this is the new value. So that means after this write operation change the value 20 to 40. Right? And if there's a commit operation, whether commit is done, which transaction is committed or which transaction is rolled back. Right? So there you don't have before and after, because only read and write has before and after, and only write has different read before and after values. Okay. In some transaction logs, we have something called backp, nextp as well. So that shows when do you have the next log entry of that transaction. For example, you can see after this log entry, T1 related entry is here. Next T1 related entry is here. Sometimes they keep track of that also. Right? So this transaction will keep track that, okay, my previous entry is transaction time number 3. But that is optional thing, because anyway, but when you're reading, you can find out which transaction is doing that. Okay. But in the past papers, sometimes you will see next backp, nextp as well, but you don't have to worry too much about that. Right. So what are the transaction handling strategies when it comes to related to recovery? Right. So there are some strategies. One approach is steal, no steal. So that is one. Either you have database will decide steal or no steal. The database will decide force or no force. Okay, so that is steal versus no steal. One particular aspect we have to think. Another aspect is force versus no force. Okay, force versus no force. So what is mean by steal versus no steal? Another name for steal is immediate update. Another name for no steal is deferred. Deferred means you postpone. Immediate means you do it immediately. It's very easy to understand. So steal or immediate update means a database management system can flush a value, say a particular transaction change value of X from 10 to 20. But still this is not committed. This transaction is not committed. Even before committed, if the database may flush this to the disk file, saying now X is not 10, it is 20. But this is not yet committed. So then we say it's a steal operation. Commit කරන්න කලින් disk එකට ගහුවා. So then someone will ask, why do you want to do that? Because maybe that particular page is supposed to be written back to the disk because it has been there for some time. So then if it is still is enabled, so those values will also be written back to the disk. Right? Immediate update. It gives you better performance because you don't wait until commit to do the writing back. Okay, it doesn't mean that we are always writing. When periodically when we write, if there are still things, we don't delay it. We just write that also together with other changes. Okay, that is steal. So steal is good for the performance, but it makes recoverability complicated because now things which are not committed are reflected in the hard disk. If this failed, now that change is already there, which is uncommitted transaction. The transaction is failed because of the disk failure and the system failure, but that uncommitted transactions data will be in the disk. When you recover, you take from that point to recover. So therefore, stealing will make recovery difficult, but it makes the performance better. No steal means your recovery is easier because only committed data is in the files, but performance-wise, it is not good because you are keep things delaying. So the next concept is force versus no force. Right? So force means all cache pages updated by transactions are immediately flushed or forced to the disk when the transaction is commit. When a transaction is commit, if there are data pages that has dirty data related to this transaction, which is not yet updated to the disk, those will be flushed. When a transaction is committed, all the data pages having the dirty values due to this transaction will be flushed, forced. That is what is meant by force. So therefore, when a transaction is commit, it is guaranteed that those data is now pushed to the data files. Okay. So again, it's less performing. Why? Every time a transaction commit, you have to do a disk flushing. You can't just do it at your regular time or when you have the resources, time. So therefore, forcing is not resource efficient wise, it is not good thing to do because it forces the database management system to do additional tasks. Every time commit is done, you have to do flushing. Okay. But it makes recovery easier because all the committed transactions are reflected in the files. Right? So you can see when recovery, these are two conflicting interests. When the performance is considered, recovery becomes difficult. If you want to make recovery easier, the overall performance will be less. Okay. So force will make recovery easier, but overall performance will be less. But no force means there is no forcing. When the commit is done, we don't force, or the DBMS is not forced to flush it. It can flush it later. So therefore, the overall performance is good. But again, recovery will become more complicated because there some committed transactions are also not reflected in the DIS at the failure. The transaction log says committed, but it doesn't guarantee that it is in the DIS if it is no force. Right now, you must have understand about what is steel versus no steel, force versus no force. Okay. So the most challenging situation is when you have steel and no force. Steel means uncommitted transaction details are flushed to the database. No force means committed transactions data is not flushed to the database or the files. So that means your file has uncommitted data written as well as committed transactions data not written. But this is the performance wise the best one. But this is where the most complications occur in recovery in case of a failure. So we say that in steel and no force, we have to do both undo and redo operations in the recovery. But if it is no steel and force, that is the rosy, and that is the simplest thing to we do when it comes to transaction recovery, because all the committed data is in the file, all the non-committed data is not there. So therefore, it actually we don't have to do anything at all as a sort of a recovery. We just have to keep track of which transactions are committed, which transactions are not, because there's nothing related to halfway transactions, because halfway transactions are definitely not done, and all the full committed transactions are 100% done. So this is the easiest scenario to recover, but this is the most challenging scenario to recover. But the databases usually, for efficiency, they go for steel no force. Okay. Then there's another concept called shadow paging also. So there you keep a copy of the same data twice, the old copy and the new copy. Okay. So then also its recovery is faster because you have a shadow always. When one fail, we have the other. Okay. But that is just for your information in case they ask what is shadow paging. But we are interested in recoveries. These four possibilities: steel versus no steel, force versus no force, and four possibilities. And in your exam, mostly you have to assume that it is steel and no force. That means you have to do both undo and redo. Okay, unless the theory question asks. Right, what are the recovery strategies? Again, different databases use different recovery strategies. So this is the most popular recovery strategy we are going to discuss. Okay. So that is recovery via rollback and roll forwarding. So this is what we are going to discuss. Okay. Recovery via rollback and roll forwarding. Okay. So recovery via reprocessing is not much use. Right. So that is why it is mentioned first. What we are going to discuss is recovery via rollback and roll forwarding. Because in this approach, we can't go back to our old timestamp and we do everything from that point forward. So to do that, you need very precise backups and everything like that, which is not very practical in most of the situations. But this is the practical situation where we can recover from any sort of a failure. Okay. So we use an algorithm or strategy called Algorithm for Recovery and Isolation Exploiting Semantics, or ARIES. algorithm. Okay. ARIES, Aries algorithm. So don't worry too much about the name. So it is good old days they come up with these long names. මතකනේ ENIAC, EDSAC, EDVAC කියලා computers වලට නම් දැම්මා ඒගොල්ලෝ. Right. So there we identify phases. Right? Phases. What is known as analysis phase? Then what is known as undo phase or backward phase, and the redo phase. Okay, redo phase. Right. Analysis phase, undo phase, and redo phase. Okay, so it's 12:03, right? Okay, we'll do something like this. So we'll finish this one in the evening class. Okay, small thing, but we have to do some past papers. Okay, we'll finish this. Okay, right, we'll finish. But I'm not going to do any questions. Questions we'll be doing in the evening. Okay, 7. Right. So what is done in the analysis phase? So what we do is we start at the last checkpoint. Remember where we have something called checkpoints or the save points? Remember? So time to time we take a save point where we freeze the transaction, flush it. Remember? And write a save point entry. So these things doesn't have any example of save point. So here in the middle there will be some entry saying save point. Let's say whether you have it in your past papers. Yeah, you can see no save point, right? No, you can see checkpoint. So from time to time, if there's a checkpoint or save point, that entry will be there. That entry will be saying there's a save point at that point, or there's a checkpoint at that point. That is where you stop everything, flush the data, right? Flush the data, and again you restart the not restart, you resume the transactions. Okay. At checkpoints, you know that it's a stable place. Stable place means all the dirty data is flushed to the database. But it doesn't guarantee that still the forcing can happen, right? Forcing can happen. That means with the uncommitted data will be in the database. That you are not going to undo, but definitely at the checkpoint, the things have been flushed, right? Things have been flushed. If something is done in the transaction level, it is done in the database as well, files as well, because the flushing is done at the checkpoint. Okay. So therefore, checkpoint, the save points are sort of a stable places, stable things. Otherwise, we have to go to the last save point, and we have to start recovery from that point. But when you have frequent save points, in the recovery phase, we have to do less work. Okay, right. So in the analysis phase, we start at the last checkpoints, record and proceed to the end or the failure. Right? We start from the last save points, and after some time there's a failure. Of course, when there's a failure, there's no record saying failure. All of a sudden, the transaction log has finished. Right? So that is the failure means the last entry. Because after that time, the DBMS is crashed due to hard disk failure or the system failure. Okay. So you start with the last save point and you analyze up to the failure. Okay. So the analysis phase compiles the set of redo and undo to be performed. Right? So it marks which things we want to redo, which things we want to undo. Okay. So how to identify the undo things? All transactions that were in the progress at that time must be undo. Okay, all the transactions must be undone. Then what has to be redo? Committed transactions must be redo. Okay, committed transactions must be redo. Okay, that is how we do it. So we first create an undo list, then we create a redo list. So in the redo phase or redo stuff, we move certain items from undo list to the redo list. So initially we have undo list, then we have a redo list. So if it is something related to committed transaction, because you see that it is committed after sometimes when you keep moving, now you find that that transaction is committed. If it is in the undo list, some activities, we are moving into the redo list, because committed transactions we have to redo. Right? Uncommitted transactions we have to undo. So therefore, initially we take everything as undo. But if it is committed, we take it to the redo list, because now you know that it is not, we have to force this to happen because this transaction is fully done. Okay, it's very simple concept. So at the end, all the uncommitted transactions related things will be in the undo list. All the committed transactions related things will be in the redo list, because committed transactions we have to redo, uncommitted transaction we have to undo. Okay, I hope you get the idea. Okay, so initially everything is in the undo, but when you identify a commit, those actions related to that committed transaction, we put it into the redo, because it's a committed one. Okay, now system now work backwards through the log, undoing the transactions in the undo list. Now we have the undo list and the redo list. Now we have come to the crash point. Now we start from the crash point and go backward, undoing all the things that is in the undo list. Okay. Then it works forward again, redoing the transaction in the redo list. So that is why we call it roll back and roll forward. First we do all the undos which are in the undo list. Then we do the redos which are in the redo list. Okay. So by the time some of the items are taken from undo list to the redo list. Okay. So that is how it is done. Okay, that is how it is done. Right. So I explain you, the undo is done for the uncommitted transactions. Redo is done for the committed transactions. Okay. Right. So we'll do a question in the evening class. Okay. We will do a question in the evening class. Then we will be doing all the other questions as well. And if you have time in the evening class, we will be moving to the distributed databases as well. Most probably we will have time. We may not have time because these questions will take a lot of time. But if you have time, we will definitely start the distributed database as well. And also I'm planning to have another extra class as well, because we want to have some more extra classes and finish this, because then we have to do the network subject as well as system administration. But that is not a difficult subject. Those are very straightforward things. Just you have to remember things also. Okay. Right. So I will let you know when you have the next extra class as well. Anyway, we have the evening class. Evening class, we are going to finish the transaction and hopefully start the distributed databases as well. Okay. Right. We stop at this point because we started at 8. Right. So we'll be meeting in the evening. Okay. We stop.